Hello, are you able to hear me? And I see the screen.
Yes, we can.
All right, thank you so much. I think I shall not waste a lot of time. I shall begin straight away because we have a lot to cover. Now, can I find someone who will be reading for us today so that we don't shift to different people? It might also take time. If we can just get a volunteer who will be reading for us. Anyone?
For MCQ1, right?
Yes, MCQ1.
Okay, let me see if I can access the.
I'll be projecting, so you'll be reading on this other end if you'll be able to see.
Okay, that's fine.
All right.
If they don't take my light.
So I think at this slide, I just left it there. I think the last time we were here at slide number 8, right? Did we cover to slide number 8?
I think we started having issues on slide number 5. We're struggling with network from slide number 5.
From slide number 5?
Yes.
Wow. Yes, you can read slide number from this slide number. I think this is slide number 5. So you can read it here. Yes. So first of all, you say that everything is okay. The audio and the screen, you're able to see everything.
Fantastic.
Now, when things get worse, just inform me because it's not a good idea for me to go further. Yet you are not getting me. You can just inform me by WhatsApp, or you can just let me know.
Oh, okay. Can you just say hi on WhatsApp now so that I can easily track you?
All right.
And quickly text you once everything is going on.
Okay.
Okay, I've seen you.
All right. So let me know in case of anything.
All right.
So you can begin to read.
Access the quality of water sources. The quality of water sources is a pretty big deal. We'll turn to the water quality table to find records where the subjective quality score is within a certain range and visit count is above certain threshold. This should help us spot the water sources that are frequently visited and have a decent quality score. Should I go on?
Yes.
Number 5, investigate any pollution issues. We can't overlook the pollution status of our water sources. Let's find those water sources where the pollution test results come back as dirty or biologically contaminated. This will help us flag the areas that need immediate attention. By working through this task, we'll not only be answering President Nadali's call to explore the database and extract meaningful insights, but we'll also be honoring our SQL skills. Honing our SQL skills. It's a win-win situation. So, are you ready to dive in and start exploring with me? Let's do this.
So essentially, in these parts, like in these, you can see they are listed 1 to 5. Basically, this is the task that the data team is assigned to do. So the first thing, they were to get to know the data, and the second thing they were to dive into the water source, and there's some description there. The third process was to unpack the visits to water sources. Then the fourth process was to assess the quality of water source. Then the fifth was to investigate any pollution issue. So basically, he was listing now the real thing or the real work begins in this slide. So you can just read from this slide 1. Basically, not slide 1 actually, from this part 1, number 1. So that we begin with this one. Can you hear me?
Oh, sorry, I was muted and I was reading.
Okay.
Start retrieving the first few records from each table. How many tables are there in our database? What are the names of these tables? Once you've identified the tables, write a select statement to retrieve the first 5 records from each table. As you look at the data, take note of the columns and their respective data types in each table. What information does each table contain? I don't think they showed you at the academy, but when you access a new database in MySQL, a handy initial to run is show tables. This will give you a list of all the tables in the database. You should see something like this. It mentions the table. It looks like someone took the time to name all these tables pretty well because we can kind of figure out what each table is about without really having to think too hard. Water source probably logs information about each source, like where it is, what type of source it is, and so on.
All right. Let's begin with this slide. I think essentially we are beginning is like we are beginning from scratch, and this database I think is altered. So let me just drop the schema and reload the one which is not modified. So let me load a SQL here, SQL script. I don't know where it is exactly. And then let's go the sizes. Then let me load everything here. So let me close this other window because this one we are done. You can, when you refresh on this other window, you'll see that you have this database there. Now in this slide, they are saying we start by retrieving the first few records from each table and identify how many tables are there in our database. I think this should be in, the first thing to do, to identify the type of tables in the database. And then now after this one, you can as well identify retrieve now the few records from each table. And then you can as well, what are the names? So you can as well use the data dictionary table to identify the column names, the table names, what they stand for, the explanation on the same. So let's begin by first trying to get to know what are the tables. Remember, you can just list the tables here. You can just use the GUI to identify which type of tables they are here. Or using these stuff, then you can list all the tables. However, with the code, you can first of all have to identify the database you're using. But because you realize that here we have two databases, and they might have several. So you have to identify first of all to specify the database that you're using. So we are going to use this database. You define first of all the database that you're using, then you can use the show table. You can use the show table command. Is it the spelling
Tables.
or tables? Yeah, okay. Show tables, and then so when you run, it will list now the tables for you that are available here. You can see it's a replica of what is here. We have the data dictionary, employee, global, water access, location, and all that. So you can retrieve the type of data, tables that are here. And then the next thing, it was to retrieve few records from each table. Now in that case, we can use something called, now we can select, you can select, for example, select all the columns. We use asterisk to define all the columns in a table. we use asterisk. If you want to identify particular columns, to retrieve only the records for particular columns, you can specify the column names here instead of these asterisks, separated with a comma. And then because I want everything, then I will specify. We will specify from first of all the database, which is MD. And then, for example, if you want to retrieve from the data dictionary, you specify the data dictionary here. And then, because they also said that you have to limit, you have to retrieve the first few records from each table. So to retrieve, I think you can use this to limit. They say to retrieve few records. So in that case, you have to use the limit command. And then you can limit to whichever records you wish, like let's say something like 10. Then it's a good practice always to close statements, a query with a semicolon. Though it's not a must, but it's a good practice to do so. And then when you run, then it will retrieve only few records here. Like for me, I used 10, it has returned 10. When you use something like 5, you limit it to 5, it will return only the 5 records in this table. Now, the other thing, so basically you can do the same for other tables to get to know this database. And I think people who are here, they are familiar with these tables. If you're not familiar, you can just go to the data dictionary here. Let me just remove that limit, and then you can go through, for example, each table. For example, the first one is the employee table, and understand each column in the employee table, what it means, what it stands for, and all that. So I don't want to go in step by step to retrieve few records from each table here for the interest of time, but the procedure is just the same. You select all from the table name, then you can limit, or you can choose to leave everything the way they are. So you'll be able to access information from each table. So basically, this was the first, this was the first command that we used to run, actually to list the tables. The first command here, to list the to show the tables here. So you can always do that. And by the way, guys, there's sometimes we use the comment. So the comment, they just help developers identify or maybe make comments or do something that it won't be executed. It won't be executed by the SQL engine. So to define a comment, multi-line comment, you use these two / then asterisk. Then you can add in here your comments. Let's say, for example, this is a comment. This is a comment. Now you can see when you run, it won't be executed. It won't be executed. You can see nothing happens here. Now, if you want to use you just want to make a single line comment, you can specify by 2 hyphen.
Help me tell your mom that I won't be around today.
Yes?
Okay, she has finished cooking.
I've been calling her since now. Number is not going. I just found your number now. Wait, what?
Hello? Is someone talking?
No, we can
continue.
Okay.
talking on phone.
Alright. So when you want to make a single line comment, you use these two hyphens, two dashes. If you want to make a single line comment, use these 2 hyphens separated by a space here before the word. So this one will make these lines a comment. Now the shortcut to make everything a comment, for example, you've written many stuffs and you want to make everything a comment, you can just do a Control A. You select everything. Then when you click on Control, then at the /, it will help you to do many things, to make many things a comment. And this applies in different languages. So this is just a simple trick that you can always use. Now let me use here a PHP project and show you how you can as well make it on other languages. Let me just
Quickly,
yes please.
how about when you're working from the notebook, the Jupyter notebook? How do you add comments?
When you use a Jupyter notebook, I tried it fails. I think this one works on the IDEs alone.
Oh, yeah, because I think when you put comments, it brings an error when you're running your queries.
Yeah.
Okay, thank you.
I'm sorry, Eve, I'm not hearing you clearly, please.
Oh, I was asking him how are we supposed to put comments on the Jupyter notebook when you're running the SQL queries? And he's saying whatever we're doing on SQL Workbench may not be applicable on the Jupyter notebook. Because I was telling him when I was trying to put in the comments when I ran the queries there was an error.
Now, if you want to use a comment on Jupyter Notebook, remember Jupyter Notebook is strictly for Python, so you have to use the hash. You have to use the hash to define a comment on Jupyter Notebook. It's not like the SQL. So if you can't use the shortcut like the control then a / to make a comment on Jupyter Notebook. But if you want to define a comment, because Jupyter is strictly for Python, because when you install an environment, you will specify, for example, if it were R or a Python. So if you choose Python, then at that Jupyter Notebook, anything you install, it will work more on so the comment there should be, unless you first begin with the magic commands, then it will identify the rest of stuff like the comments, the SQL comments. However, the Jupyter Notebook is strictly for Python or whichever language you specified when you install the environment. So this command applies on different languages. So for instance, if you're working with Visual Studio Code and you are unsure about which command to use, sorry, I've just opened something which is not closed folder. I should have installed. I just want to show you how you can use that trick. So this is just a PHP project that I did, a CodeIgniter, a framework that is for PHP project. So basically all PHP projects you can use anything. Let me just get something here. Now, for instance, if you want to make everything here a comment, you can just select everything, then I do the control, then the /. You can see this way you can know that in PHP use the 2 / to make to make them a comment. So this is PHP, and then when you try something like I don't know if I have React here. Let me find a different language. Let me try Python. I think I have Django project here. So I don't know which project. Let me use this one. Anything here. So this one is Python for Python. Now for Python, I say that I use hash. You can see the file, the extension for Python intends with .py. Now, for instance, if you want to make everything a comment here, you can just use the control, then the /, then it will make them a comment. Now, if you're using the TypeScript, JavaScript, and all that, you can as well try the same. I think I have React here, but I don't want to go into that. I think you understand the concept here. So this one can be also a good method, because a comment you must use them, especially if you are collaborating with other people, and especially if you're working on SQL databases, because you might be a data entry specialist, you're working, for example, with the different analysts and all that. So you have to comment your stuff so that they can identify or understand the statements or basically the commands that you are working on that part. So when you comment on your script, it might be better. You saw for the Explore AI, the one that they gave us, you saw they had very detailed, documentation of the scripts. So if you are unsure about which command, which way to use to make something a comment, just use the control then and the forward slash. And that one applies if you're working on an IDE like a Visual Studio Code or a PyCharm or um, RStudio, or those are IDE for different languages. I think it will work. So this was just a bit the way. Now to uncomment, you can use the same command control, then at the forward slash it will do the uncomment. It will remove the comment. Now because I want to refer to it perhaps later, let me just make it a comment, and you saw that I will use this command to do what, to list the tables, here at this part. This tables part, and then to access or to retrieve few records from each table, you can always use this command. You select columns. When you use asterisk, it will mean that you are selecting all columns from that table, and then at the from clause specify which table you are trying to access. Now we are trying to access the data dictionary, but this data dictionary should be in this database. So if you don't specify the database, and then I think it will bring an error. So you have to specify, and then now this way it will return everything. And for example, if you're working with many records, it might slow down the processing speed of your computer, or it might crash. So you have to use the limit clause or a keyword or a command to limit the number of records to return. So you can use the limit keyword, and I say that is a good practice always to close the SQL statement with the semicolon. That is not a must, but to show that you are done with that statement, that query. So this way you're able to retrieve few records from each table. So I think we've captured everything in this part. Is it? I think we've covered here everything here. It looks like someone took the time to name these are tables pretty well. I think we talked about the naming of tables yesterday. So to write something which is readable for other people to also understand. If you want the reference, I think the link was shared in the group yesterday. You can find more details on how you can rename your tables, columns, name, and different ways on how you can name your columns or a table. Yeah, I remember the same approach applies on, remember soon we'll be tackling Python for those who are doing, those who are doing data science. So you will find out that the variable names, you have to define them in a particular way, for them to be readable, actually to be readable. So you will find out that we have several approach on how you can name your data, variable, so that it can be readable by other people. Remember, when you write something on yourself, you can read, but if you send it to someone else who has not interacted with your code, it might be difficult to read. So there are always several approaches on how you can use multi-word, for example, multi-word variables, so that other people can identify your stuff very well. For example, if you are defining variables and all that, or classes, you have to use a good name that can be readable. So we talked about the naming, and you can see this stuff can be readable very well. For example, it is multi-word. Remember, a table you can't use space. For example, data, then space dictionary. So you can't use it that way. It will bring an error. It will throw an error. So you have to link them to be one word. So to separate multi-word, you can use the underscore, or if it were camel case, you can the first word begins small, or the first word be all small, and then the subsequent first letter of the word begins in a capital. I think for you to understand, let me try to do this. But I talked about this stuff yesterday. I don't know why I'm trying to repeat. But for example, if it's camel case, so for example, my long table table name, my long table name. Now you can see for me I'm able to read it quickly because I'm the one who wrote it. But if it is someone else who wants to read, can take time to identify. But if you use something like a snake case sometimes it's called the underscore case. So someone can easily identify or know that this table name is called this is my long table name. So this one someone can read your table name very well. Or alternatively, we have another technique called camel case. So for camel case, every word, despite the first, only the first word is small. For example, if it were, for example, word, everything on the first word is small, but the initial of the subsequent words, they are capitalized. Like along, you can see it's capitalized. T for table is capitalized. Then our name is capitalized. So this approach, we call it camel case. Then we have Pascal case. It's just like a camel case, but now every word, every initial word is defined with the uh, is defined with their capital. Every initial word has the capitals. So you need to know this one when you're working with the table so that people can understand what you are doing. So if you are using a multi-word column names or table names, ensure that you use something that is readable. That's why we can you can see here they say uh, you can see it looks like someone took time to name all these tables pretty well because we can kind of figure out what each table is about without really having to think so hard. Yeah, you can see the approach they use is a snake case or an underscore case, underscore approach. So you can easily read the tables itself. And so you can tell, for example, what underscore source probably logs information about each source, like where it is, what type of source it is, and so on. Does anyone have a question here, or we can move to the next slide because I think we have a lot of slides and that we have to finish today. Can we go to the next slide?
Please, good evening, everyone. Please carry me along. I don't know where we are. I just joined not quite long.
Okay. So basically,
We are sorry.
yes,
We are
please help me.
we are in MCQ1, and we are going to the slide that has we've just finished get to know our data. So we are moving to the next slide.
Okay, thank you.
All right.
Thank you so much. So you can continue.
Okay. Okay. So let's have a look at one of these tables. Let's use location so we can use that killer query, select star. But remember to limit it and tell it which table we are looking at. So we can see that this table has information on specific location with an address, the province, and the town and the location in it. And if it's in a city, urban or not, we can really see what location this is, but we can see some sort of identifying number of that location.
So I think this one we've just done that, but with a different table. So it's the same command. You just select everything, every column from the table name, and then you define now the column. So the table name, not the column, the table name. So in that case, they said the location table. So with this location table, when you just limit to, for example, I see them, they have used 5, they have limited to 5. With this one, you can you can return 5 records. Was it location table? Let me confirm.
Yes, location table.
Oh yeah. So I think this is the command. You can just run this command, select all tables from this, select all columns. This stands for columns, right? This is for columns. It will mean that you are selecting all columns. You want to return all columns, information on all columns from this table name. So location table, but this location table is in this database. Remember, we have several databases. You can have several databases, so you have to specify the database. And then because he said that we can limit, that's why we use the limit, so that we may not return everything, every record. And if you try to compare, you will see that it resembles what it was returned on his end. Are we good with this slide?
Yes, we are. But I just want to ask a quick question.
Yes.
This MD Water Service database, it's in is an SQL database. Can we load it on the Jupyter Notebook?
The Jupyter Notebook. So if you want to work with Jupyter, you must link. No, you can't load it on Jupyter. On Jupyter, you can load only the CSV files and also JSON files, but you can't load the database. So you have to link it with the MySQL Workbench, so that you're able to not work with the. Basically, you can load it, but you have to use the the MySQL Workbench. You have to use the MySQL Workbench to help you have the connection, but you can't load it directly. But stuff like the CSV or JSON files, you can just pull them in the notebook directly. But for database, not direct. You have to establish connection with MySQL Workbench before you use it.
Okay.
Yes.
Okay.
Yes, please.
No.
Have I explained something or?
Yes,
you
are correct.
Okay. So
Yeah.
Yeah, we can go to something. Okay, I think at this part I can read. So let's look at the visits table. Again, for the visits table, is the same approach. Just change from location to the visit. To visits. And then when you limit it to 5, it will return the first 5 records. Yeah, like that. I think this is what they got. I think it's 5. Yeah, it is up to 5. Yeah, 5. You can read for us this part here.
Yeah, so it is a list of locations, location ID, source ID, record ID, and date and time. So it makes sense that some assigned employee ID visited some location, that's location ID, at some time of record, and found a source there, source ID. Often the ID columns are related to another table. In this case, the source ID in the visit table refers to the source ID in the water source table. This is what we call foreign key, but we'll get more into this next time.
Yeah, so basically the foreign key reference to the primary key. Now the primary key is like the unique identifier of a particular object or a particular record. So for example, if I want to access information about a particular customer, a particular user, you'll have to use the primary key. Now when you use it on a different instance, the same key, it will be the foreign key. The original one is the primary key, but the one that refers to it, it will be now the foreign key. The foreign key. So I think there's not much there. We can go here. You can read for us kindly.
Okay, so let's look at the water source table to see what sources normally ID columns are related to another table. Sorry. So let's look at the water source table to see what a source is. Normally, ID columns are related to another table. Okay, international table.
Yes, please. Can you finish?
Okay, nice. Okay, we are getting somewhere now. Water source are where people get their water from. Okay, this database is actually complex. So maybe a good idea for you is to look at the rest of the tables quickly. You can just select them, but remember in SQL there will be a data dictionary somewhere that document all this information. So you should read that as well and even keep a copy of that close if we need to find information quickly. The data dictionary has been embedded into the database. If you query the data dictionary table, an explanation of each column is given there.
Okay, before we do that, and I think this like a real world, a project. So we should always follow an example here because so soon after we are done with this course, we'll be doing the same. And you realize that the best approach, you first of all saw that when you are defining the table name, you have to use something that is readable to other people. And then the second thing that we are just trying to realize here is that you need also to have a table for data dictionary to list, for example, to help people identify the columns. For example, you wrote something that you see that you feel like it is readable to people, but it's a good practice as well to explain to people about those columns name or a table name so that they can have a good idea. So this is what I think I've picked from this part. But also, there's something here. So let's look at the water source table, and we see that let's get there. We see that we have the ID. Normally, ID columns are related to one another. Like you can see, I think it's water source. I think it's something like the water source. The water source. I don't know how I can try to do this. So it says water source. So water source, let me try to run that and see. And then you can see that we have the source ID. And then he says that the source ID is something that ends with something like an ID. It is related to one another. He says, let's look at the water underscore source table to see what the source is. Normally, the ID columns are related to one table. For instance, the source underscore ID, it is most likely to be related to another table. So essentially, when you go to maybe different tables, when you go to a different tables, for instance, something like this is source ID. So most likely, when you go to which table, water source, this is water source. I don't know access which I don't know, but you can go to each table one by one, then you'll find out that this source ID is related to another. So if you go to step by step, let me just do that. I think it's not a big deal. Let me just do. This is record ID, so this one is not there. You can go to the water quality, and then it's not there. You can go to I can go to water quality. Is it visit, or let me try to go to the visit, and then again it's not here. So you can, but that's why they say that you go through the tables to get familiar to everything. So like you can see, for me, I'm struggling to obtain and the table that has the source ID because I think I didn't go through very well. I think that should be something like, I'm not sure, source ID. Source ID, visit water quality. Did I check it? How can help me retrieve that? Source ID, location. Is it source ID or a location ID? Water pollution and yeah, source ID. Yeah, I got it. So you can see he said that something that ends with underscore ID is usually related with from another table. Like you can see now in this let me just delete this other one so that I may have few scripts here. So we have the well pollution, and then the water. No, is it? Yeah, this one we have the in the water source we have the source ID, a column, and then also in the well pollution we also have the source underscore ID. That's why he's saying something that ends with the underscore ID, it is always related to another table. I think. Does anyone have a question, or I can just go to anything? I think there's no much thing to explore here. Does anyone have a question, or I can go to the next slide?
You can go to the next slide, please.
All right, thank you. I see host master. I don't know if he's the one who is reading. He says that he'll be changing the power source. Someone can help read till I return. Who can do that?
Okay, I can assist.
Yes, please.
So I'll start from 2, right?
Yes. So we are going to the next problem. So the first one was to identify or to get familiar with the tables. Now we are going to the next problem or a next step. It is to dive into the water sources. So you can just begin to read.
Okay. Now that you're familiar with the structure of the tables, let's dive deeper. We need to understand the types of water sources we are dealing with. Can you figure out which table contains this information?
You can read
Should I go
everything.
ahead?
Yes,
Okay.
just read everything.
So once you've identified the right table, write a write an SQL query to find all the unique types of water sources. So I get this when I run it. So are we doing the query?
Okay, so let's do that then. Now he says now that you're familiar with the structure of the tables, let's dive deeper. We need to understand the type of water sources we are dealing with. So can you figure out water sources? So when you just see that question, water sources, you can tell from these tables. You can just predict a table because it was well defined. So you can easily tell which type of table you are going to deal with because I said we need to understand the type of water sources. So can someone just tell us which table can we most likely use it for that to query? Now, for the sake of time, let me just say water source. Water source. I can just tell it is water source. Water source, and so it is water source that you can have information about the wells, type of water sources and all that, based on this information here. And then he says, once you've identified the right table, write a SQL query to find all the unique type of water sources. So in that case, we'll most likely use the distinct command. So because I see that you need to identify the right table, write a SQL query to find all the unique type of water sources. Like you can see when you run this statement, it is a script, select all from this table, and then you run the water sources table, you'll find out that we have a tap in home, which is repeated several times. Tap in home broken is also repeated several times. Wells, it is repeated several times. So when he says to retrieve unique records for this type of water source, I think he said type of water source. unique type of water sources. So you can as well, the SQL has a command called distinct. So the distinct, you can use the distinct. I don't know which is the spelling for distinct. They are distinct. And then now, because he specified he was interested in the type of water source, you can specify that column. And instead of retrieving all the records, you can use the type of water source. And then when you run this query, it will let me just use one script so that we can refer to it later, perhaps, if we need. So when you run this statement, two statements, then it will return the distinct type of water source. So it won't be repeated like as you can see here. Because I limited it to 5, it is returning 5 records. But let me just do this. Let me just remove this limit keyword here. Let me comment it, and then let me uncomment this one. So as you can see, we have repeated elements, type of water sources here. There are many, there are quite many here. So in this case, you'll have to, because it says that you have to retrieve distinct, unique type of water source, then you have to use the distinct. Now the distinct command help us to retrieve only unique values. So this one avoids duplicate, removes duplicate from your results. So it will only return the distinct type of water source. So for example, if it were tap in home, it will only return the one instance of tap in home. And then if it were well, it will only return one type of one instance of well, in the type of water source. So let's try to run, and then you can see it is true. It returns only this instance, unique type of water source. So when you use the distinct command, it will definitely return unique, a unique value of the water source. So does anyone have a question here, or we can move next to the next slide? Let's do the confirmation quickly, because I want us to cover everything today. All right,
move on.
Yes, just stop kindly, because I don't want to speak to myself like at the other time. So so I think we can read this part quickly. So I think this is just to kind of understand. You can see our information tallies or match what he projected here. So yeah, so he's trying to explain to us what this type of water sources is, and I think at this part we can go quickly. And I want us to pay keen attention here, because I will not be repeating or explaining these steps. So you can just read for us quickly, and I will finish this description part, and I go to the next thing.
Kindly show me the code you entered for that query, please. The previous slide. I just want to see the code you entered.
For this one?
Yeah.
Oh, so in this, so this is the command.
Oh, use distinct.
Yeah, distinct.
Okay.
Yes.
Thanks.
Okay. Now, so someone can just read for us quickly this part.
Okay. 1. River. People collect drinking water along a river. This is an open water source that millions of people use in Majindogo. Water from a river has a high risk of being contaminated with biological and other pollutants, so it is the worst source of water possible. This is a river. in the province of Sokoto.
Oh, sorry.
Okay. Well, these sources draw water from underground sources and are commonly shared by communities. Since these are closed water sources, contamination is much less likely compared to a river. Unfortunately, due to the aging infrastructure and the corruption of officials in the past, many of our wells are not clean. This well is at 146 Oka, Okabi Road in my hometown of Yaoundé.
Oh, so basically in this case, he's trying to explain to us where that contamination comes in. Like you can see, for example, this for this first case, the river, you can see this like this the water that people depends or drinks from, and then you can see people are stepping into the water. So most likely this is a poor type of. There's a lot of risk when you drink this this water because it's highly contaminated. And this the I think this is the first the leading water source that is at risk because you can see you don't know what people have stepped on, and you can see they just step on the water, and you can see the jerrycans here. It means that they are going to take it for drinking. So you can see it's at high risk. And then the second one it's well, and basically as you can see this kind of well, it's not that appropriate. It is underground, and you can see there's surface water here, so you don't know what will enter inside, and and all that. So it's not also. I think it's not closed. So basically this one is closed. So this contamination is less likely compared to the river because the river is an open source. So basically for this one you can just tell it's a bit lesser risk compared to the river. So you can just go to the shared tab, read for us.
Share tab. This is a tab in a public area shared by communities. This is share tab from 18 Winga Lane, Hawassa, that serves about 207 27,000 people.
Okay, so it's
I
trying
mean,
to.
2,700 people. Sorry, my dear.
Okay, no problem. So this is another type of water source, and you can see that this one is less likely to have contamination because it's kind of well maintained. So you can go to the next thing, tap in home.
Tap in home. These are taps that are inside the homes of our citizens. On average, about 6 people live together in Majindogo. So each of these taps serves about 6 people. This is a tap in my country's home, in my uncle's home in the capital city, Dahabu.
Oh, so basically, in each tap, for example, if you have a tap in your home, and let's say you have maybe a family of 6, so it means that each tap is going to serve 6 people. Yeah. So, and I can see this one is less. This like you can see it's not that bad compared to the rest. It's not. Though the environment can tell it's not good, but this one is more likely to be much safer compared to the rest. Mm-hmm.
Broken tap in home. These are taps that have been installed in a citizen's home, but the infrastructure connected to that tap is not functional. This can be due to burst pipes, broken pumps, or water treatment plants that are not working. This is a water treatment plant in the town of Kintapo that serves about 1,000 people.
Yeah, again, if the water treatment plant is broken or is not working, it will mean that people are drinking water which is not treated. So it's also an indication that it might have some impurities. So you can read this slide.
Okay, an important note on the home taps. About 6 to 10 million people have running water installed in their homes in Majintogo, including broken taps. If we were to document this, we would have a row of data for each home so that one record is one tab. That means our database would contain about 1 million rows of data, which may slow our system down. For now, the surveyors combine the data of many households together into a single record. For example, the first record, AK whatever, is for a tab in home that serves 956 people. What this means is that the records of about 160 homes nearby were combined into one record, with an average of 6 people living in each house. That's 160 times 6, which is equals to 956. So one tab in home or tab in home broken record actually refers to multiple households, with the sum of the people living in these homes equal to number of people served. Unpack the visit to water sources. We have a table in our database that logs the visit made to different water sources. Can you identify this? Write an SQL query that retrieves all records from this table where the time in queue is more than some crazy time, say 500 minutes. How would it feel to queue 8 hours for water?
Okay, first of all, let's try to understand what it means here. So basically, he says that, let me just, so it means that this region, basically that region Majindogo, it has a population of around 10 million. So it will mean that if they were to document everybody, every record for a person in that, every person, it will mean that I will have around 10 million records. So it will mean that, for example, if your computer is not that good to retrieve all the information, it will be a hassle for your computer. So what they did, for example, if you have a house and you have maybe 6 people depending on a particular, let's say, tapping home, so they will count 6 people is one element. So essentially, it will mean that, for example, if so what this means is that the records of about 160 nearby home. So for example, when they say 956 people, let's try to get that table. Which table is that? Is it visit? Let's get not visit. Which table? Water source. Water source. So number of people served. So for instance, tap in home for this ID, for this source ID. Remember, you can use the primary key to obtain this type of source ID. I think we have I don't know if we did a query for that previously, but now you can, for example, let's assume, it's already here. Tap in home, it's here already. Now for tap in home, you can see it is 956. 956, it means that within this 956, it will mean that what they did, they calculated or they divided. So essentially, the real data, it will mean that it was, you divide by 6 people. You divide by the 6 people, then it will mean that it will have the real one. It was to have let's first of all see this part very well. So for example, let me just read this part. About 6 to 10 million people have running water installed in their homes in Majindogo, including broken taps. If I were to document this, you will have a row of data for each home, so that one record is one tap. That means that database will contain about 1 million rows of data. So which means slow our system down. For now, the surveyor combined the data from in household. So for example, this record for tap in home serves 956 people. What this means is that the records of about 160 homes nearby were combined together or combined into one record with an average of 6 people living in each household. So it is 160 times 6 to be 156. Yeah, so we are just right. So when they say 156, it will mean that what they did a cumulative summation. For example, if a household have 6 people, then it means that this summation, what they did that 6 people like one record for one record. So it will mean that it will be 160. So 160 times 6, that's when you get this 956 value here. 956 value there. And then here they say unpack the visits to water source. We have a table in our database that logs the visits made to different water sources. Can you identify this table? So anything related to visits, you can tell is like a visits table, right? If I'm not wrong, visits table. Let me minimize other queries here. So you can just tell that is a visits table. You can use the commands, or you can just because you know the commands. So I don't want to waste time rewriting those stuff. So I'll just use the GUI so that it can generate for us the the commands here. And then you can see this is the visits table, and then you can see it records the number of visits, visit count, maybe time in queue, and then assign the employee ID. And so you can tell that that is the correct table, and pack the visits to water source. We have a table in our database that logs the visits made to different water source. So I think that's the correct table. And then here they say write a SQL query that retrieves all the record from this table where the time in queue is more than some crazy time, say something like 500 minutes. How will you feel to queue 8 hours for water? So essentially they want us to retrieve some records or some records that has visits which is more than 500 minutes. 500 minutes is like 8 hours. When you do the approximation, it's like when you convert from minutes to hours, it will mean that it's something like 8 hours. So when you do 500 minutes divided by 60, it will be something like 8 hours, almost 8 hours or something 8 hours, related to 8 hours. So he's saying that how would you feel to queue for water for 8 hours? It doesn't make sense. For instance, for you have to go to the hubs and do the project there, or to do the peer reviews. And then before you go there, for example, you want to fetch water for taking bath, and then you take 8 hours in the queue. So it's not, it doesn't make sense. It's not appropriate, not good. So what he is saying that I want us to retrieve those records so that we can see which records are they. So let's try to do that. Now here we'll use which type of sublanguage of SQL. Can just someone tell me which sublanguage of SQL we can use here? Remember, I have different type of, and I talked about those languages yesterday. The DDL and many others there. So can someone tell me?
DML.
DML.
Yes.
Okay. Yes. What about the DQL? Can we use that one? Now, if I want to retrieve, if I want to query, if I want to use this where clause, because now we want to filter. Can we use this one? Or can you explain to the people what the data manipulation, language works, or works yet? Kindly. Hello? You can just try to explain to us what the DML works. Alright, it does. The commands therein.
Okay.
Yes.
For the data manipulation language,
Yes.
it's usually to get information from the table. Usually the primary commands are usually select, where, order by. So what it does, just it derives information from the table. To put it simply.
Yeah, that is very, very correct. And since we are using different commands here, we introduced the where. Now the where, I think it falls under the it falls under the DQL, the data query language, because now we want to maybe do the filtering. So we can use this where clause, because it says that we want to retrieve um, the records from the table where time in queue is more than some crazy time, let's say 500. So we can use now the where clause to do the filtering. So it means with this command it says we are trying to select all the columns from this visits table where time in queue, time in queue now. So let me close this, the other one, where so it should be visits, right? Yeah, visits, where time in queue, it is some crazy time, some crazy file of time, like more than, I think it said something like we can retrieve all the records from the table. Time in queue is more than some crazy. When you use the more than, when you say more than, it means that now the filtering should be, when you have to use this angle bracket for greater than, when it is more than. Something which is less than, use the angle bracket for less than. But now in this context, they said more than, so we use something greater than some crazy value like 500. So this one will filter, will filter. This one will filter, will return the results for all the records that has time in queue which is more than 500. So let's try to run this command and see what will be the output. So the output, and then you can see that it has returned. Now initially it was initially it returned everything. Time in queue, you can see it also include 15. Others they have zeros, so it means that they are not queuing. This one has 62, so this one hid everything. But you can see now in our filter, everything is more than 500, so it means that they were queuing for more than 8 hours. So every record that is returned here is more than 500. So when you use now this DQL, data query language, this filtering clause or a command, then it will retrieve only the specified condition there. So basically we have obtained this one. I don't know if someone has a question on this slide, or we can go to the next one. And I'm so sorry guys, I think I'm not involving people, because I think I can do that one in the next slide, because I want us to cover this thing. I know sometimes response from people is a bit slow, so we could take time. So I'm trying to go faster so that we can cover this thing and work on MCQ 2 and 3, and also do the assignments. So that's why I'm trying to go fast and doing everything alone. I don't know if inconveniencing people. Is it appropriate?
I think you're doing fine. I just want to suggest for people like Eve and others,
Yes.
that are already working on what you call it, Jupyter Notebook. If you can just show us just like a brief reminder how to connect, so they can also be using, while you are doing this, they can also be doing it on Jupyter Notebook and be, still be following along while you are doing it here. So you keep them familiarized as you are moving forward.
Oh, that's a great idea. So now in that case, Jupyter Notebook, the Explore AI team, they recommended us to use it from the Anaconda environment. So I'll have to launch first of all the Anaconda Navigator. Remember, you can use the Jupyter Notebook, just an independent software. You can just install it on your operating system and use it. However, in this case, we are using the Anaconda environment. So in most cases, you have to launch first of all that Anaconda environment. Now, the Anaconda environment, I said yesterday, contains packages for data science materials, machine learning and artificial intelligence, packages. I remember it includes, modules for R programming and Python programming. So for Python, we can have it contains stuff like tkinda for GUI compiler for matplotlib, or a NumPy, or a SciPy, or Seaborn. We have many modules for data science. So when you use this environment, you won't have to install it into in your entire system. You can just install in your environment. And so to create an environment, I guess people know how to create the environment. So I'm going to so if you don't know how to create an environment, I think I will record it and also upload it on YouTube. We uploaded on YouTube. So I think if you have a question on how you can install those modules, I'll encourage you to follow along this video, because I just want to show you people how to connect with MySQL Workbench. I don't want to go on to explaining how to install, for example, how to create an environment and all that. So I think I will have this part, this integrated project through to walk through. It is 3 hours 20 minutes. So if you can find this video, you can go through and understand in fact how to install the Anaconda. I think in this video we covered how to install the Anaconda, how to install the Jupyter Notebook and all that, and we had other explanation on the same. So in this one, as you propose, I want just want to show people how they can do it, how they can connect with MySQL with MySQL Workbench and work on the notebook. So in this case, let me just have a file that has already the commands. In this case, I think I'll have to go to my portal and then data science. So there's another file that had the notebook. So I just want to use that instead of writing the commands fresh. Interacting, so this select where. Let me use this notebook. This is a walkthrough. I just want that not here. Here it is. Let me use this one. Now I don't know. I guess the configuration it is. I'm assuming that they've installed everything required. So I just want to show them how they can connect. Let me use any project like even this. Let me use this one. I think this one I installed for this one let me open it, this one, because this one I think I already have the modules. I think my computer is always slow, so when I try to create a new project and show people step by step, it might take a lot of time. But remember, we have the video for that. If you want to follow along, there's a video for that. You can just find a reference there and then a rewatch. However, in this one, just want to show people how they can connect with Notebook. So you click on this play button, open with Jupyter Notebook, and then you give it hours to open. When it opens, you can find where that you can create a new file. By the way, you can just create a new file. By the way, let me use a new file. Let me just create here a new file. I will use this button for new. Then I use this Python 3. Now we will upload this one on YouTube. So by the time we are recording, this one is Python 3. So those will be watching in future. I don't know which version it will be, but this is Python 3, using Python 3 interpreter. And then I remember the titles you can always change. and give it your preferred preferred title. But let me just say title. I don't want to type things. Title, then you can rename. And then now I say that the first thing that you need to have now in the environment, you have to install something called IPython SQL. Now the first thing that you need to install is PyMySQL. Now the PyMySQL, let me list it here. And let me use now. I see that when you're using Jupyter Notebook, you have to use the hash to define a comment. So use a PyMySQL. So with this PyMySQL, this one helps you to establish connection between the Jupyter Notebook and MySQL Workbench. And then we also have another file called another module called IPython SQL. So this one with this one, this is like this is like the environment for which you can execute this SQL query in an interpreted environment, like something like a shell. This one helps you to work on this SQL project, very well. This SQL script. Then we also have another file called another package called SQL Alchemy. SQL Alchemy. So with the SQL Alchemy help you to so with the SQL Alchemy, because we see that this notebook is for Python, and if you created an environment in this Anaconda, it will be for Python. So with the SQL Alchemy, it helps you to write the magic to have the commands for the SQL. Now with this one, you can write your SQL command very well with this SQL. So in most cases, when you install it on the system, we need to install the latest version. And I remember most latest version of stuffs, they are not always stable. They are not always stable. A version they haven't tested perhaps with different modules to work on different modules. So that's why it is always unstable. It can't work well with different. Now, for example, if you want to install a stable version that you'll be able to work without issues, you can specify. If you want to install this SQL Alchemy, you can specify the stable version that will be able to connect well with other modules and be able to work with the this stuff. So in this case, I'll show you how you can install, for example, the stable version for this SQL Alchemy. So you just use the pip. Now pip. Now first of all, before you do anything, you have to run what? You have to run the commands. So I think let me just use this one. I think this one is much easier than for me to write. I hate writing a lot. Let me just use the one which is already written.
How did you get your download file?
The download.
Your download file.
I download from this.
No, I know. I said, how did you get your download file? But you only give documents, desktop. How did you get it?
Oh, so basically, when you just launch this Jupyter Notebook, it will list the folders within your operating system here. So you can navigate, for example, if it's desktop. Remember, this is a replica of what it is there in the File Explorer. So, for example, what is in the desktop, you can see it's Django photography. When you open your File Explorer on your operating system, and then you go to on the desktop, you can see it's a replica of what is there. So it is listing the folders within your computer. So if you want to navigate, for example, to the downloads, you click on the downloads. So it will go to the downloads and list every file that is at the downloads. Have I answered?
Yes, you have. Consider.
Okay. So I say that by then they explained this one very well. So load and activate the SQL extension to allow us to execute the SQL query on a Jupyter Notebook. So with this command, when you run these commands, you're able now to execute the SQL query within this Jupyter Notebook. Remember I said that a Jupyter Notebook is for Python. So if you write here your SQL statements, it won't understand unless you load first of all this stuff so that you may be able to work well. And I remember for you to work well with this one, you have to first of all have this file. This IPython SQL for you to be able to work with this one without issues. So if you don't have this file, then when you run this one, you'll have an error. Like you can see for me, I don't have an error because I have that file in my system. Now, the next thing is now the connection here. Now the connection, you can just do this. You can just go to your workbench and then go to home. Then when you click on this setting button, you can find all the information like the host name, port number, and all that. So the password. So I think here, let me try to explain this one. So this, to establish a connection, you have to use this format. First of all, the magic command SQL, MySQL plus PyMySQL, then the root. This is the username. This is the username because we are using the local host. My user is my username here it is root. You don't know. You can use your user preferred username, but there it is root. And then a password, you can specify your password here. You can specify your password for this project. I'm using LimeTech. And then so the local host is the alias for this host, for this for this host name or the endpoint. And then the other thing is now the database name. Now the database name is not United Nations in this context. We are using I don't know why I keep on opening this file. These are Anaconda. So so what you do, you can now define the database. I don't know why I closed. It is bringing the issue. Yeah, I think it has worked. I think everything is now closed. So this is the database name, and let me copy it. So here instead of the United, so this is the port number. So the port number, you can as well access it here. I don't want to go to there, but because I think it will have another error. But on the settings, you'll see the port number. So the port number is what you'll feed in here. The port number, then the database name. So in this case, I'm using the United underscore. So what did I copy? Should be MD underscore water underscore services database. So here I'll replace with this database, and then now if everything is okay, when you run, it should work. Like you can see, mine is connected. When it says connected, it means that the connection is established. But there is something that I wanted to show you earlier on how you can install the stable version of that magic, the package for magic commands. So let me just create a new slide. So you just use the PIP. PIP is the package manager to install the Python modules. For instance, the SQL Alchemy is the Python module. This is a SQL Alchemy is a Python module, so you have to use the PIP, and then because you want to specify the version. Remember now you have to use the install command. Install command, and the SQL Alchemy. Then you can specify the version. When you use these true equal operator, you can specify the version. For example, 1 point something point. I think it was 4. The stable version for this one is 4.4. Then when you run this one, remember you must first of all have this one. You must run this file first of all before you do this one, because it might have an issue. When you run, when everything is okay, then it will install that module for you. So it may take some time, because for me I already installed it earlier, so it say the requirement already satisfied. And I remember it can't work directly. You have to restart now this notebook, restart the kernel. Remember when we were to create the Now here, when you were to click on the new, we were to say Python 3 PyKernel. So this is like this Jupyter notebook is that thing that is there, Py3 or whatever. So you have to restart this notebook for you to be able now to implement other stuff. When you just run your stuff without rebooting or restarting the kernel, it won't detect the changes. So you have to click on the kernel tab, then I click on the restart. So when you restart this kernel, then it will mean that everything is updated. You can now begin to write your SQL query. So for instance, in this case, you can so this is the database, right? MD_water services. So you can specify, select all from now the table name, because now this one is a different table. I think which command? Let me just use a different any command there. Let me just use any command. Let me just use any command so that you can just show you how it works, and then the rest will be doing the same. Remember, the commands are just the same. The only difference is that here you are beginning with the magic command. So let me just remove everything here, and then let me run this one. And then now when you reboot this it was called what? This complicated name, PyKernel. So first of all, because you reboot, it's like a computer that you have just restarted. So you have to load stuff, you have to open tabs and all that to access elements and all that. So in this case, you have to again load this stuff, because this one helps you to establish now command, the connection, not connection actually, to convert this Jupyter notebook so that you may be able to write your SQL query. So you have first of all to run that one for it to work, for this one to work. So when you run again, if the command is correct, and then again I forgot, I should have run this one as well. And then when that one runs, then you can begin now to write your queries here. So you can see now you can retrieve the information here. But now I don't want to go to this one, because now the commands are just the same. What we are doing here, it is the same like what is here in the notebook. The only difference is that there you are beginning with the magic command. The magic commands are these ones, to modular SQL. This one helps you or identifies that you are working on magic command here, so that Jupyter notebook can interpret your code as a SQL script. Is it okay? We move on. Have I explained well?
Very well.
Okay. I think let me minimize this, but I will not using this browser. Now, back to this one. So this part I think people have understood. So I closed my editor, my script that I was using, and everything was closed as well. But I believe people understood how to retrieve the records that has more than 500 records, more than 500 minutes in the timing queue. So does anyone have a question here, or we can move to the next thing? Please do so quickly, because I want us to finish this thing. Then tomorrow we begin MCQ 2. Then on Saturday, tomorrow is Thursday. Is it Thursday? Thursday, I think we have time. So tomorrow we can do MCQ 2. If we will not cover, we can extend to Friday MCQ. Then I finalize. Then I will do the MCQ 3 plus the test. So if we do it quickly, I think it will help us to cover a lot. So you can just respond quickly. Did you understand this slide, or we can repeat, or we can go to the next slide?
I think you should continue. When someone may have a question, I'm sure they'll bring it up, because time. If you want to finish with you.
please. Thank you so much. Thank you so much. Yeah. Who was reading? Can you continue?
Okay. So where are we starting? This is the table I get. How is this possible? Can you imagine queuing 8 hours for water? I am wondering what type of water sources take this long to queue for. You will have to find out. You have to find that information in an. You have to find that information in another table that lists the types of water sources. If I remember correctly, the table has type of water source and a source ID column. So let's write down a couple of these source ID values for our result and search for them in other tables. Okay, those are the results. If we just select the first couple of records of visit tables without a where filter, we can see that some of these rows also have 0 minutes queue time. So let's write down one or two of these.
Okay, thank you so much for that. So I think it's I have to repeat everything. I'm compelled to repeat everything because I have to use that one to explain. So let me just go to. I think it was the visits table. And then so the query was now before you filter, before you do the filter, he says, I think it is he. He says that if you just select the first couple of records of the filter without the where, you can see that some of these rows also have 0 minutes time in queue. So let's write down one or two of these two. So basically, without doing the query, you can see that some time in queue, like this one, it has 0, 0, 0, and that the rest they have 0. So let's do now the filter with the where clause where. And by the way, if you have a question, you can just ask because I don't want to ask people if they have a question. I want us to go faster. So if you don't ask a question, I'll assume you are getting things right. So in this regard, let me just go to the columns table, time in queue. Where time in queue, they said it's more than some crazy value, 500. 500 is approximately 8 hours. So when you just run this command, then you'll retrieve those information. Time in queue is of more than 500 hours, and essentially this is what they got here. This is what they got here, 515, and then when you compare, you can see also hours beginning with 515, so it is the same. And then now the other thing here, I'm wondering what type of sources takes this long to queue. What will we will have to find that information in another table that lists the type of water sources. So basically, when they say type of water source, you can just tell which table is that type of water source. Type of water source, and then you can see that there are some relationship. You can see we have the source ID, and then also in the visits we have the source ID. Let me close these other scripts so that let me have few items here, employees here. Let me delete this one. So you can see that there's some relationship. Like you can see we have the visit source ID on the visits table, and also on the water source we also have the source ID. So it means that there is some relationship. So he says that he wants us to check which are these records, which are these sources that people can take this long to fetch water. So we can just take a few records and try to retrieve information on the same and try to understand what are these water sources. So in that case, we'll use our query, our where clause to filter. So we'll say, no, we are doing what? We are doing, we want now to obtain, sorry, we want now to obtain the time. Let me use the visits table. We want to obtain, we want to identify which are these water sources that has this higher value that people can queue in this long. So we can copy the source ID because this shows the relationship. This is the foreign key for the water source. So let me just paste somewhere. So he said that you can write it somewhere, but let me just paste it somewhere. So we have these two values. I want to use these three values here. I want to use these three values here to identify which are these water sources. So in this case, we want to retrieve it from the water source table. So we'll have to use we'll have to use now the where class. Let me use the capital. I have to use the where. Now so here you have to specify now the source ID because this is the one that shows the relationship between the water source and the visits. The visits table, you can see there's a relationship, the source ID. But they told us earlier that when you see something that has an ID at the end, underscore ID, there's some relationship with another table. So we can use this one, the source where source underscore ID. Now because we are using different type of, we want to retrieve three information, we can use the in. We can use now this in command so that we can specify the range. We can specify the range. Then in the range you can list. Remember this thing are strings. So in your range should be inside the quotes. Now the quotes, either single or a double quote, define a string. Let's paste this one. And I'm so sorry guys, I'm not involved in people, but tomorrow I'll be telling people to give us their command. But for the interest of time, let me just do this. So with this command, so basically here we are trying to retrieve, we want to return all the columns from the water underscore source, water from water underscore source, and I want to retrieve, just to identify which are these sources where people can queue for more than 8 hours. So we just want to tell which are these water sources that people can queue, because now here you can't tell, there's no that column that display the type of water source. So because it's in another table, we're using it as a foreign key to retrieve the data in the primary key. So the primary key has the information about the water source, type of water source. So when you use this command, I think if it's correct, it must return those type of water source. And you can see all of them, it is shared tab, because a tab, I think they usually removes water slowly, and I will have many people queuing. So I think this one will take a lot of time, and it makes sense. Like you can see, in fact, this one it is 37 hours, 3,704 minutes. When you convert it to hours, how many hours it will be? And just someone just do some simple calculation there. 4 divided by 60. Now again, I don't want to go to that. I think people will take another 1 hour to respond. So let's just move to the next thing. This was just by the way. So we are just trying to see what are these sources where people can queue for this long, for this long time, So by the way, it wasn't time in queue. Let me just get it right. This is number of people served, not time in queue. Sorry guys. It is
Okay, so
yes.
Yeah. I was going to say that because I calculated it and I'm seeing like
Yes.
62 hours something.
Oh, basically, I was being I was confused there. Sorry for that. So I didn't read this column. I thought I was in the visits. So basically, these are the number of people it serves. So it serves 3,004 people. So imagine people queuing. The 3,704 people queuing. So it means that the last person will have to wait for around these hours. These hours, and that person with the ID, this one, he'll wait for that a long time. So sorry for that. Once again, this is not the hours time in queue. I didn't read the column very well. So this is the number of people that are this shared tab serves. So so I think we are good with this slide, right? So once again, it says we can also try to filter where we have the 0 minutes. So the same approach. So for the same approach, you can just go there and then do um, 0. Let me just return 0, exactly 0, where time in queue is 0. And then I choose anything. For example, what was the primary key thing? It's source ID, the one that shows the relationship. So I'll paste it here. Again, I'll go again and I'll copy something else. So basically, I'm pasting the type of water source, which there's no queue at all. I don't know which one is that you can just go straight in and just fetch water without a queue. So let's try to identify that one. So I'm replacing this key with the one that has 0 time in queue. So when you try to return, then you can see that the first thing is well. And the number of people served, you can see it is minimal, like at 210. So it means that you won't take that long to queue because the number of people it serves is very few. And then a tap in home broken. So most likely because it's broken and systems are contaminated. Not system. The water is contaminated. So people don't like that water, and it makes sense. We have few people, and you can't so you can see now there's no this queue there. And then also the wells, Now remember when they say the number of people are served, it is 252. It doesn't mean that they go to queue all of them at that time. So perhaps someone has gone in the morning. For example, someone fetch enough water to cover, for example, 2 days. So it doesn't mean that the people are queuing 252 people are queuing on the same day. So and it makes sense that there's no queue there. So are we good with this slide, I guess? Uh, so you say that if you have a question, you can just say, you can just ask. Now, if there's no question, then let's go to
So,
yes,
so it's not like a question. So I think because sometimes I always have issues with running these SQL codes,
yes,
but I'm seeing that the problem is from like me understanding the table,
yes,
understanding the tables given, so that if you are asked to school or you're asked to kind of execute a certain thing, you already know the table where it is so that you can refer to it. So I think that's what I should work on my own.
yeah, yeah,
Thank
yeah.
you.
Yeah, and by then this project, and also I've also learned a lot from based on this project, and I remember this one also helped us for our future project. And we realized that the first thing these people defined they had the data dictionary, so you can go through the columns name. I understand everything, go through all the tables, and if you are not aware about the particular column or a particular table, you can just refer to the data dictionary and get to familiarize with the with your tables in the columns before you even begin with the queries. And by the way, I think that is the best approach they used, because also on the slide that was the first item, just to identify the to understand the the tables the columns name and all that, so that it might be easier when you want to do the analysis, so it will take you less time. So for example, just to identify, for example, which table has the visits, maybe the time in queue, because you are familiar with the tables, you can just quickly identify that one and work on it. So we should always, I think for me, I will always follow this approach that these people are using here. That the first thing, you go through the data dictionary, identify the columns name, get familiarized with the tables, the columns, before you begin. And if you have also realized that one, I think it is beneficial also for this walkthrough.
And just to also say something, I think Ijoma made a very, very fantastic point because
Yes.
when they ask you a question, for instance, like a column might be in that water source table, and what they actually want, the main column might be in the visit table, but since they didn't mention the visit table, you might be running the query on the water source table and you're not able to get something, and you now wonder why somebody did the query on the visit table to get it. But knowing the columns in the visit table and how they align with the questions can help in this regard.
Absolutely. Thank you so much for that. So we all agree that it's a good practice always to familiarize with the tables. And by the way, that's why I said earlier that when you are defining your column names, or you are defining your tables or databases, use something that is descriptive, that so that when you share it with someone else to work on, they might also find easy time to understand everything. By the way, in any project, for me, I usually do software engineering. So if I want to collaborate with a different another person, uh, I'll have to use the comments. I'll have to use the comments so that when I give them to understand the code structure and everything, it can be easier. So it's a good practice for any person, any developer or any coder to know how to name their stuffs, the names, the naming, and also just make another person have an easy time to understand the tables, the columns, or for example the codes if we are working on codes, so that it can be much easier for them. So like for example, if you are familiarized with the table, the columns, you can see it is much easier. So this is something that I think I'll go home with from this project. And thank you so much for highlighting that one. Hmm? So I think we can go to this slide. Have we covered this slide, or was it the other one? I think we are here. So you can read this part.
Okay, so I chose these two. Should I start from there or where?
Yeah, just read.
I chose these two. Okay, so now back to the matter, the water source table. Let's check the records for those source IDs. You can probably remember there is a cool and a not there's a cool and a not so cool way to do it. This is what I get.
So to make people be in line with this one, let's try to use the exact one. So this key, these are source IDs. Will retrieve the information or the record that has 0 time in queue. So let's just put that one here, so that at least people can see that we are in line. So he said 2. But I remember for us, we have done another, and we obtained a different result. But let's just use his so that we can see if it resembles. They match, they match. So let's try to run, and you can see that the first one is tap in home 476. Let's try to compare tap in home. Which record did they use here? Tap in home. or should I copy exactly this one here? But at the same, that's the approach. That's the approach to use, and this is the approach to use. You just specify. I don't know which one they were trying to retrieve. I'm not sure if they were trying to retrieve the one with the 0. I think that they are trying to retrieve records that has more than 500 time in queue. By the way, so you can see that the 3398. So that's 398. So this one I think they are trying to retrieve the records that has time in queue which is more than more than 500. You can see it makes sense because if 3,000 people are using the same thing, for example, if it's a tab, it will make sense that the queue time it will also take long. And then if I want to retrieve the one with the 0 time in queue, the same approach, and we did that one. And here it says I added a couple of others, sorry. If you check them, you'll see which sources have people queuing. The field surveys also let us know. Let's just go to the next one. You can just read here. Or if someone has a question, they'll just ask here. Yes, go ahead.
Should I go ahead with reading?
Continue. You are saying?
Please continue.
Yeah, continue.
Okay. Access the quality of water sources. The quality of our water sources is the whole point of this survey. We have the table that contains a quality score for each visit made about a water source that was assigned by a field surveyor. They assigned a score to each source from 1 being terrible to 10 for good. For good clean water source in a home. Shared taps are not rated as high, and the score also depends on how long the queue times are. Look through the table record to find the table. Let's check if this is true. The surveyors only made multiple visits to shared taps and did not revisit other types of water sources. So there should be no record of second visit to locations where there are good water sources like taps in homes. So please write a query to find records where the subject quality score is 10. Only looking for home types, and where the source was visited a second time, what will this tell us? Sorry, I'm struggling to look at this. So I get 218 rows of data, but this should not be happening. I think some of our employees may have made mistakes. To be honest, I will be surprised if there are no errors in our data at this scale. I'm going to send Brett Naledi a message that we have to recheck some of these sources. You can appoint an auditor to check some of the data independently and make sure we have the right information.
And thank you so much for that. And by the way, guys, before you do any analysis, you have first of all to understand the question or what you're going to do. Now, so in this context, if you just try to internalize or to memorize or to understand what this slide means, so what I got here is that what they did, the surveyors did, they assigned a score for type of water sources. So, for example, the type of quality, the quality of the type of water source. I don't know if I'm saying it correctly, but now when they give it 1, then it will mean that that type of water source it is terrible. It's not safe for drinking. And then when they give it 10, it will mean that that water is good and it is clean for the use. You can use it very well. And then So shared tabs are not rated as high, and the score also depends on how long the queue times are. The queue times are, and by the way, if you see that we realized previously, like we had tapping home broken. You saw that there were no queue because we make an assumption like because it's broken, maybe the water is contaminated, so people don't want to queue there, don't want to go there to drink water. So it can tell that um, you know um, it can tell that also don't know what I was talking about, but there's something that share tabs are rated as high. The score also depends on how long the queue times and the queue times are. So the queue times, so it depends also. You can tell that this water is not good because the queue is low. So people go for good things. So in Swahili they say that um, you know good things market themselves, but bad, uh, you have to, I don't know how to put it right, but it means that there's something that has a lot of queue and it has a long queue. It means that that thing is most likely to be pure. Like the shared tabs, they are rated high, because most people use it because it's clean. But for example, the wells or at the river. In fact, even the rivers, I think it's zero or at the wells because most people don't use it or at taps in home, broken. Now, having understanding the statements here, look through the table record to find the table. Look through the table record to find the table. So let's check if this is true. The surveyors only made multiple visits to shared tabs, and I did not revisit other type of water sources. So there should be no record of second visits to location where there are good water sources like taps in home. So please write a query to find records where subject underscore water underscore quality is 10, only looking for taps in for home taps, and where the source was visited a second time. Now they say that the shared tabs are rated high. The tabs, those tabs in home, they are rated high. So you can just tell with these 10, it's most likely the tabs in home. We shall also check that if it's so, the home tabs. Now we can write our query statement to check to do what we can write a query to find the records, the subject water query. So first of all, we need to identify which type of table that has this column subject quality score, subject quality score. So when something talks about quality, it will mean that because of this table they defined it well, you can just tell that it is water quality, because something quality is related to water quality. I can just tell this is this table has something relating to quality something. So now we want to retrieve the information that they say where subject underscore water quality score is 10, and then another keyword, another thing, the source was visited second time. So was visited second time. You can see now they haven't specified like it was visited more than second time or it was visited. This one they have just specified second time, so you can tell which command you'll be using there. So you have first of all to read and understand first of all what they are saying here, so that when you write your query, you write the correct query. So in this case, I can just tell that what they are looking is the water subject quality score, which is 10, and the other thing is the source was visited twice, a second time, So, um, so you can do the filter here with the where clause, and then we are saying the subject underscore quality water. So let me do this. Let me just open. I think for me to type something, I can write something which is not correct. So I'll say the first thing, the subjective water quality, he says, is 10. Is 10. When they say is, just know that you're using the equal. Is 10, or they haven't specified less than 10 or more than 10. It is just is. So that will tell you that you have to use the equal operator. It means that you are assigning 10. You're giving it 10. So this is the first, the first thing, keyword, or the first query that you're going to do. So you're going to identify only the record that has subjective quality score, which is 10. But we can as well have, so when you run this one, you can find, it will retrieve everything. It will retrieve anything, but you can see now the visit count, it is 1, 5, and all that. So now you have to specify the second, the second keyword here. They said, and the source was
Visit count equals
to 2.
Yes.
Yeah, so now you have to specify now. So we use the and. We use the and. Now when you use the and keyword, it means that two statements must be correct for a result to occur, for you to have the results. So when you use the and, it means that it must meet these two commands when you use the and. So anything that meets these two statements, where subjective quality score is 10 and the visit count is 2, they said 2 is 2. They didn't say more than 2, or they say is 2. So in this case, it will only return. I think in most cases they usually use it in a, I don't know, in a different line, but it doesn't matter. So that's the command. So when you run, then it will retrieve only where the visit count is, where the visit count is 2. So you can see now we have filtered where subjective water quality is 10, and then the visit count is 2. And then he says, so please write a query where what will this tell us? So we've wrote that query. Now the second thing, we want to identify the number of records here, the number of records that are here. So we can use now the count. We can use a count, to identify the number of records returned, I guess, because here he says but this should, so essentially it means that he's trying to count the number of rows. So when you see he says 218, he wants to identify what are these water sources which had the subjective quality score of 10, and then the visit count was 2. So I want to identify all the rows that has those data. So in that case, you can use the count. And I've talked so much, I think I'm having, I don't know, but let's just try to finish. So we can do the count. We can do the count here. So you just use this account keyword, then you'll be able to obtain the number of the records. So this count keyword returns the number of the number of records. So when you compare with his, you can see it is 218. Does anyone have a question, or we can go to the next slide?
I have a question.
Yes, please.
I'll take you back to the where I look through the table and I need to find the table. Okay, when I'm seeing my SQL workbench table in the schema, I'm not seeing the water quality table. Where did you locate it?
The subjective water quality score.
Okay, now before that one, there's from MD Water Services, and then the table is water quality. I'm not seeing it here.
Oh, so this water quality is it is here. When you have this database.
Oh, okay. I've seen, because
yes.
Yeah, I've seen, because I realized I was looking. Maybe I didn't write it when I was querying, writing the data. Okay, thank you.
So yeah, that's why it's a good approach to first of all list and identify the tables. So it returns us to that part where we have to understand everything. So yeah. So I believe any other question, or we can go to the next thing. And I'm so sorry, guys. Next time, tomorrow, I'll involve everyone. Tomorrow, I'll involve everyone because this one is similar that we are taking days. So let's just go to the next one if there's no question. In case of any
Please,
question.
let's go to the next one.
Yes. You can read it.
Investigate pollution issues. Patricia, sorry, what are you saying?
I don't
Hello?
know. Yes, I can hear you.
Patricia, should I go?
Oh, you are not hearing Patricia?
I can't hear her.
Okay, let me just try. Is it Patricia that was reading?
No. She was saying something, so I wanted to find out.
Her network is more.
Hello,
Yes.
can you hear me?
I can hear you.
Yes, I can hear
Yes.
you.
So I wanted to ask, in that part too, they're saying, please write a query to find records, and I think this is where I found a problem
Yes.
because I was getting yes to 18, but then there's this part where they're saying only looking for home taps. Isn't that like a necessary part? Were we supposed to work with that, or we're supposed to just ignore that bit? Only looking for home taps.
Now,
I think the query we have run is just like a general, just saying subject quality score is 10, and then the source was visited like twice, so that is equals to 2. But where does home taps come into play?
So this home tab, it is referring to this type.
So that's 10. The assumption is if it's a 10,
10
good
is probably home.
that means it's probably home.
Yes, it's a
I
home
think I
tab.
confused myself and I gave up at that point.
Okay, so you are trying to join two table queries.
Yes, and I was like, we have not even reached to the join part. So what is happening? Yeah, okay.
So this is
Okay,
referring
thank
to
you.
this one because a 10 is like pure. They say that one is like one is a terrible score, and
Yeah.
so one is a terrible score, and then they suggested they say something here that the one which was rated high
Mm-hmm.
is a bit is something like a taps something taps. So when they say
Yeah.
subjective water quality score is 10, just know that something is related to taps in home, the taps, shared taps, and the stuff. So this one is just an additional to this statement.
So that's 10, yeah. Yeah, I get it now. Thank you, guys.
Welcome. So we can go to slide
Okay.
5. Yeah.
Investigate pollution issues. Did you notice that we recorded contamination/pollution data for all of the well sources? Find the right table and print the first few rows. Find the right table and print the first few rows. Okay, that's the first few rows.
Yeah, you can just read everything.
It looks like our scientists diligently recorded the water quality of all the wells. Some are contaminated with biological contaminants, while others are polluted with an excess of heavy metals and other pollutants. Based on the results, each well was classified as clean, contaminated biological or contaminated chemical or sorry about that. So based on the results, each well was classified as clean, contaminated, biological or contaminated chemical. It is important to know this because wells that are polluted with bio or other contaminants are not safe to drink. It looks like they recorded the source ID of each test So we can link it to a source at some place in maji ndogo.
Oh, maji ndogo, yeah. Yeah, maji ndogo, it means few water in Swahili. So essentially, here, what it's trying to tell us, the first line of code is, so first of all, if they named their tables very well, we can identify where the contamination or a pollution table is. So when you try to retrieve first few records, few rows, you can identify the table where there is source ID, description, pollutant. So you can just tell. For me, I can just tell because these guys, they named their tables very well. I can know that the table that has contamination is something relating to pollution. So if I can just write here a query to do it. So let me just say select, select, select all columns, maybe from this table. We're just trying to check the table and the water pollution table. So remember, you must first of all begin with defining the database. You have to specify now the database. Then you can as well use it there at the top and then use it without defining here at the bottom. But let's just do this. Is a good approach. And then so we can limit. He said that he said something. If you he said first find the right table and print the first few rows. And guys, you'll excuse me, I'm not a good reader. So I'll limit, and for my few, it can be 5. My few record is 5. So let me retrieve the first few. And then let's compare if it's the same with his source ID, and then a date, then the first item, the pollutant ppm is 0.0. So it is I think mine has returned something else, but I'm sure that it is this table because you can see the result. It has the contaminated biological. So this tells me that I'm sure I'm in the correct table. Oh, I think mine it is 0 because it doesn't have that dot 0.0, but it is the same 0.0. 0 is almost the same as 0.0, the same thing. But so this tells me that I'm using the correct. I have identified the correct table, and then I can go ahead and go to this part. It looks like our scientists diligently recorded the water quality of all the wells. Some are contaminated with biological contaminants, while others are polluted with other with an excess of heavy metal and other pollutants. So based on these results, each was classified as clean, contaminated, biological, or a contaminated chemical. It is important to know this because wells that are polluted with bio or other contaminants are not safe to drink. So it looks like they recorded source ID for each test, so you can link it to a source. Remember, we talked about the primary key and the foreign key. So basically, on the results, you can see they had they named, for example, something which is had something. For example, the bio, I think they said something like a bio, so they gave it a name, which is contaminated with the ones which were contaminated with the one which was clean was defined as clean. Contaminated was defined as contaminated or pollution. So this one means that this water type is, it is, it's contaminated. It's just pollutants. So I think and there's not much here. So I think the other thing that I see here, it looks like they recorded the source ID. So I think there's something that they want us to know, the relationship. So the relationship, it means that you can reference it to another thing. You can see they talked about to link to a source. So when they have the source ID, it means that you can as well link it to another table. and find the type of water source here. So so let me just do this. Distinct. I don't know if this is the correct distinct. Is it C? Distinct. I don't know the spelling. Distinct.
You have to do
CT.
SCT. Oh, CT. Distinct.
No.
no.
N. Yes.
Okay.
Then single T.
Okay. Thank you so much. Thank you so much. Is it correct? Is the command correct?
Yes, it's correct.
All right. Thank you so much. It's not correct because I want to obtain now the type of water source. So I'll have to specify because
you have to specify type of water source.
Yes. Because when you use everything as distinct, tap in home can be similar to tap in home, but now the ID is different. So you have to specify. This is which table? Water source. So type of water source. So you have you cannot use now the all. So this is not what I wanted, but this is not what I wanted. I just wanted to retrieve everything and see. But sorry for that. It seems I'm kind of tired, but I just wanted to show the relationship here, the source ID and you can see we have the source ID here. So there's a relationship here. So because you can't tell the source ID here, for example, you can use that statement to fetch the information from the primary key. Remember we know how we can do that because we had a command for that. So because the source ID, you can just use the source ID and get the information, identify which type of water source had these pollutants and all that by retrieving the information with the source ID. This is the foreign key of the water sources here. So that's just to get to understand now. This is a slide. I think there's not much there unless someone has a question. So if no question, we can just proceed. I think we can write the codes here so someone can read. They can continue to read kindly.
Sorry, let me help out here.
Yes, please.
Sorry, guys, I got lost though. Okay, sorry.
Is it in the pollution table?
Yes, yeah, you can. I think the other girl, you can be helped by the man. I don't know the names. I'm using girl and the man.
Leroy.
Yes.
Leroy.
Yeah, Leroy. In the well pollution table, the descriptions are notes taken by our scientists as text, so it will be challenging to process it. The biological column is in the unit of CFU milliliter per milliliter, so it measures how much contamination is in the water. 0 is clean, and anything more than 0.01 is contaminated. Let's check the integrity of the data. The worst case is if we have contamination, but we think we don't. People can get sick. So we need to make sure there is no errors here. So write a query that checks if the result is clean, but biologically no. So write a query that checks if the result is clean, but the biological column is greater than 0.01.
You can read everything here.
Stop there for this part. Or should we read
just read everything on the top.
If we compare the results in this query to the entire table, it seems like we have some inconsistencies in how the well statuses are recorded. Specifically, it seems that some data input personnel might have mistaken the description field for determining the cleanness of the water.
Thank you so much. And as always, the first thing you have to identify to understand what they are trying to ask here, or maybe the slides, before you do anything, any analysis. So in this regard, I'll say, so what they say that they give, so any record or any pollution part that has 0, it will mean that that source is clean. That source is clean. Water source is clean. But when it has anything which is more than 0.01, it will mean that that water source is contaminated. Now here it says, so you write a query that checks if the result is clean, but the biological column is 0.01. So I think you can tell which commands we shall use here. So it must meet two statements, two statements. It must meet two statements for it to work. So the first thing, if you want to query to return the same results as you did here, so the first keyword should be clean, then the next one should be 0.01. So we are trying to identify the places where they did an incorrect entry, where, for example, they say that anything more than 0.01 it is contaminated. So we are trying to look the instances where we have clean, but it is 0.0, because we all know that 0.01 it is contaminated. So essentially, we are trying to identify if we will have a column where it says where the result is clean, but the pollution is 0.01, which means it's not safe. So we can do that one. We can do, remember, before you do anything, you must first of all understand very well before you do any analysis. So here, we want to retrieve the information from the same table, the well pollution table. So they select all. We want to retrieve all the all the columns, and then now because there's some filtering here, because they say the result should be clean, and then the column is 0.01. So we want to identify those records which had some errors. So we shall use the where clause. So this falls under the DQL, data query language, under SQL. We say that we have sub languages for SQL. We talked about that one yesterday. So we can do the query, the filtering here. So the first thing they said, the first thing, it is which table? Pollutant, so something, well, pollution. So the first keyword is what was it? Let me get there. Where the result is clean. So the first thing,
where the result is clean and biological is greater than 0.01.
All right. So so this is where the result is clean. So the result is clean. So how much you use now, because that part is a string, you have to define it with quotes. Quote is used to define strings. So clean here to begin with the capital C in there. So clean. So this is the first condition that it should meet. And then now the second thing, we shall use now the and, right? Because it must meet two conditions. We want to retrieve the records where it had an error, because they said that anything 0 is clean, and anything 0.01 it is unclean. So we want to see anything that is clean yet it has 0.01. It means that it has issues. So we shall use what? What did they say? Biological column. So this part, and biological, is it this part? And biological, I think. Is it this one? Are we together?
Yes, you are correct.
Yeah, biological. But they said here biological column is more than more than 0.01. So when they say more, use the angle bracket for greater than to show more, more. When they could have said, like for example here they said clean is, where the result is, so it means that it must be a complete match, a direct match should be clean, exactly clean. But now when it is more than, in fact here they specified more than 0.01, then you have to use now the angle bracket for greater than, then I say 0.001, 0.01, and then once again it's a good practice always to clone the statement with the query with a semicolon. So it must meet these two conditions. So the result column should display clean, and then at the biological I should display anything more than 0.01. So let's try to run. If everything is okay, should return result should be clean, and anything here should be at the biological should be more than 0.01, and this one is correct, I believe so. Yeah, so I think now you can tell that these records had issues. When you do a count here, you'll see that let's try to count to see how many records were there. You can see there are around 64 records that had the issue, the errors. So it means that it had an error because they said in their definition, in their and how they were defining those pollution. To me, they are saying that anything clean should be 0, but anything that has 0.01 it is unclean. So it means that this thing has an error. We need to do some cleaning there. Have we captured everything that was in this slide?
Yes.
Okay. Yeah, so when you compare, you can see that it is clean 35. When you just try to do a match, you can see that the first record is I'm taking biological. You can see the first one is 35, it ends with 68. When you try to compare here, you can tell that it is the same, so it means that we are in the right track. So you can read this slide. Continue. Hello, are you able to hear me? Am I lost?
No, you're not lost.
Okay.
You want us to read it, Abi?
Yeah, just read. Or are we done now? Are we done with this one? I believe.
It seems like
yes.
It seems like in some cases, if the description field begins with the word clean, the results have been classified as clean in the results column, even though the biological column is greater than 0.01. When we work with real-world data, we find inconsistencies due to data being misinterpreted based on a description rather than its actual values. Let's dive deeper into the case of the issue with the biological contamination data. Vuisai has told me that the description should only have the word clean if there is no biological contamination and no chemical pollutants. Some data personnel must have copied the data from the scientist's notes into our database incorrectly. We need to find and remove the clean part from all the descriptions that have a biological contamination so this mistake is not made again. The second issue has arisen from this error, but it's much more problematic. Some of the field surveyors have marked wells as clean in the results column because the description had the word clean in it, even though they have biological contamination. So we need to find all the results that have a value greater than 0.01 in the biological column and have been set to clean in the results column. First, let's look at the description. We need to identify records that mistakenly have the word clean in the description. However, it is important to remember that not all of our field surveyors use the description to set the result. Some check the actual data.
Okay, thank you so much. Now, when we just try to understand this part, what I caught is that there was some misinterpretation here. Like, for example, basically on the description part. So, because their description, let me try to understand much better. We get that there was some description part where it had some part for clean. The description part had clean. So let me give me a second, please. I read this one too.
So,
Yeah.
so I feel that they are asking us to check the description column. We just use the GQL to generate a table now where we check biological results greater than 0.01 and the results are clean. So if you look at the description table there, we have some description that, for instance, we have clean bacteria, Galliola gambia, we have clean bacteria. So they want us to find out all the elements in table that has description, that has clean in it, but it's contaminated. Because it's greater than 0.01.
Thank you so much. Thank you so much for helping me on that. Now, when I just read on this, when I just see this table, I can as well try to understand. So you can see the reason they added. You can see anything they say that anything that is more than 0.01 should be contaminated, and you can see the results here is clean. So the assumption is some were added as clean because in their description part it was clean. It began with a clean, for instance, clean bacteria. A clean bacteria. So people, those who are feeding on this other end, they are maybe in a hurry. They just assume that it is clean. It's clean without even checking the rest of the words. So they just assume that it is clean. Now the second thing, or the second assumption, that for example, you can see these bacteria, E. coli, it doesn't have clean in it. So the next assumption here could be like these people, they just checked, and they just check on the actual data. They just did a real, checking, and I found out that the result was clean. Actually, the water source was clean, so they just ended here clean. Yet this description part is bacteria. So the first assumption was they added clean because the description part had clean on it, and then the second assumption was they did a real check. They did a real check, and they realized that that water source is clean. So even if it had biological more than 0.01, maybe it had an error on the recording, but when they did the cross check or the cross examination, they found out that those water sources, it was clean. That's why they said clean even though it has the bacteria. So I think this the assumption or not is highlighted here, right? Yeah, I believe.
Yes. So I think from the query you have written, we don't need to delete everything. We'll just leave where biological is greater than 0.01. Then instead of having and results, I think we'll now have and description. Maybe like and the percentage clean. So you show that whether the clean comes before or after it. Because I don't know if there are ones that comes after it, but I limited my own table. As you run your own, I also ran I limited my table to 10 so that it doesn't slow my system down.
Okay, so
Yes.
we are going to do that. Now, it must be in these two conditions. It must be in these two conditions. You can see that these where these are description, where this description part, it has it has what it has it has clean. It is in this filter, and these are clean, and then 0.01 where we have this clean part. So we can as well extend, for example, if we want to to do again the other filtering, we can go, for example, we want to obtain, first of all, let's begin with let me do this, let me comment this one, or I copy first of all, then I comment, then because we might reference it later, then let me replace it here. So these are the condition that it must match. First of all, the first two conditions it must match, and then the other condition now we want to obtain the one that has. I think I'm distracted. Someone is unmuted. Can someone mute kindly, so that people can hear what I'm saying? Question 1. Hello? So now we can see now these are clean. This clean bacteria, it is obtained. Not really. We are using now the results. So anything that is clean, so it must meet these are two conditions. So actually for the results, because I want to identify, to find the descriptions where it has this clean part, where it has clean in it. So we shall use the wild card keyword here, or a character called like. We shall use the like. We shall use like, and then in this like, because I want to, they said that something that begins with that clean. You can see the description field begins with the word clean. So what I'll do, I'll use because it's a string. Remember, anything character is a string. Anything integer, anything with numbers is an integer. I think we talked about the data types in one of our sessions. So we are trying to look for something that begins with the word clean. So we use the modulus at the start. Then I follow by that word clean. Clean begins with a capital. Clean begins with a capital. So the first thing, it must be, the result should be clean, and then the next filter should be what? Should be the next filter is and, where biological is 0.01. It means that it must be polytant. It must have some polytants in it. And then now the third thing, that third filter in the now you can see there's an error here. Someone can tell there's an error.
Yes, the description column.
I didn't include the description. Sorry for that. So you have to add that description here, right? Is it okay now? I think there's an error.
There's still an error because we are supposed to have the like is not a direct how do I put this? Where is the like is not a query language.
Oh.
Yes, so it's a description. It's a descriptive language. So, for instance, we have where result is this, and we've said biological is greater than this. So we need something to tell us that the description should be like should have like clean. I don't know, maybe I'm saying it properly. Let me try and write.
I think this one should be here. Wait. Sorry for that.
at that, we'll still need like something to connect that description. Is it and?
No, and yeah, sure. By the and by this, you are right. Should be and because it must meet this condition, so it must be and. It must be and.
Yes.
Let me put them in a single line so that I think people
Yes,
can
so that you
understand.
can see it clearly.
Wow, that's wonderful. Thank you so much. Thank you so much. That's the goodness with the discussion. You can learn from one another. So with this statement, it will mean that it's going to filter the result where it is clean. Then at the second condition, it must have more than 0.01. Then in the description part, it should contain something which is which has a clean in it. When you use the modulus at the start, it will mean that it must begin with the word clean. When you add it at the end, it will mean that it must end with the word clean. Now, when you use the both at the start and at the end, it will mean that it's going to look something that has exactly the word clean, the word clean. So let's try to filter and see if, first of all, the command is, correct and it is wrong. And the query is wrong. It's wrong. So I think we have to rethink on this one.
I think we need clean.
I think you put the modular after clean.
After clean also.
It should be after clean.
No, there should be in front of clean and there should also be after clean. But there should also be space, underscore. That shows there's a word that carries it. Put a modulus there too. I think it's important because we never can tell.
But as well, I think let's try just run. But I think, oh, okay, that's wonderful. Thank you, thank you for that. Again, I've learned something. Thank you so much for that. So basically, when you use these modulars here at the start and the end, it will mean that it's going to look in the description part anything that has clean in it. Then you can see it has filtered everything that has clean in it. And we see that it is clean bacteria, Giardia lamblia. Then the other one is clean bacteria E. coli. So basically, we've done this one, and so we've identified these. We've just retrieved the columns or the rows where the description part is clean, and then those people, they mistook the word clean. They thought that the contamination was not present, then they added clean. So we've identified, we have just retrieved those columns where the description had the word clean, and just doing a filter there. So are we good with this slide? Does anything, have we omitted something here or have missed something?
No omitted anything.
Okay, so I can go to the next slide. I can read kindly.
Okay. I'll read it. Please, if you are still here, I want to read. Please, you can still go on. Just assist. Okay, let's go. That is. I just want to be sure.
Are you able to see the screen?
Yes, I've also opened the PDF myself so that it's a bit clear.
So it's slide 23.
Okay. Hint. To find the description search, to find this description, search the word clean with additional character after it, as it is what separates incorrect description from the records that should have clean. The query should return 38 wrong descriptions. Now we need to fix this description so that we don't encounter this issue again in the future. Looking at the results, we need to see two different descriptions that we need to fix. One, all records that mistakenly have clean bacteria, E. coli, should be updated to bacteria E. coli. All records that mistakenly have clean bacteria, Giardia lambelia, should be updated to bacteria Giardia lambelia. The second issue we need to fix in our results column, we need to update the results column from clean to contaminated. Biological, where the biological column has a value greater than 0.01.
Okay, so the key thing, I think, at this hint part, I think we've done that. So to find this description, search for the word clean with an additional character after it. So this is what separates incorrect description from the record that should have clean. So the query should return 38 characters. I'm not sure, but let's try to check if it will return 38 rows, not character. So should be count. I wanted to write clean instead of count. So now let me try to run this one and see if it will return. Yeah, it has worked. It is 38. So it has returned 38 records. And then we need to fix this description so that we don't encounter these issues again in the future. Looking at the results, we can see two different descriptions. Basically, we can see we have this part for. Let me do this. Let me undo this. This thing. Now, when you just run, you see that it will have two categories here. The one that has clean bacteria Gambia, and then the other one is clean bacteria E. coli. So all records that were mistakenly have clean bacteria should be updated to bacteria E. coli. And by the way, guys, it's not a good idea to modify your entire database. Is a good practice if you want to do the auto, if you want to to update your stuff. It's a good practice always to make a copy. So we can do this one in the main. Once everything is done, that's when you can merge it, or you can add it to the main. To the main table. You can push it there. So all record that were mistakenly have clean bacteria guardian should be replaced with this one. So I think we can begin by first creating a copy. All right, can we begin by creating a copy of this table? And then now we do the changes, right? Can we begin with that one? Are you asleep? Are you asleep?
I'm not asleep. First one, these tabs on top of your screen.
Yes.
How are you able to name it first? Water quality. Because when I tried popping up the tab, it was just giving me star.
What is that? I don't understand.
Look at your screen now.
Yes.
Blue is highlighted, water quality, right?
Yes.
Yes. Did you name it?
Not really. I didn't name it. What I did, I was just open it via the GUI. For example, if I want to open the well pollution, I just click on this table, then it will appear here.
Okay.
Yes.
Okay. Learn something now. Yes. What did you say you want us to do now?
So the thing that I wanted to do was I see in here they say that we need to do an update here, and I suggest that is a good idea always before you make any changes to your real table, you make a copy. By the way, the explorer that guy, I think I don't remember the name. He told us that it's a good practice always to make a copy, so that in case you make something which is not correct, you can always revert to the original thing. So that's why I'm suggesting that before we make the changes here, the one that I is just suggesting here, we first of all make a copy of that table, right? Can we do that? Before we do the changes, do you agree we make a copy?
Yes, I agree we make a copy.
Okay. Now, to make a copy or to create a different what? To create a different, to make a copy of a table, we can we use what we use we use a create table. But the create table is to create new table. Create table. We are going to use the create table, and we are going to use this database still. Database name. So it is create table. Then you can define the table name. Now this is going to be a copy. Don't want it to be renamed because it's a copy. Let me use something like a copy so that we can distinguish it from the original one. And then so this one will create a table, a copy of a table named well pollution copy. So when you just run this one, it will create a table, but it won't have those records. So if you want to have the records for this well pollution, then I will have to use the AS keyword. You have to use the AS keyword so that we may use the information that is in the other table. So here you'll open the parentheses, and then I'll do it. I'll copy this one, and then select. Let me just paste it here, and then I'll remove these comments. So we are selecting all. We are selecting all from this table. We are selecting all from this table. So when you run this command, it will generate. It will create another table, copy table, but the information or the columns and everything will be the same as the one it is in the original. In the original table. Yeah. So let me run. I don't know. Did I run it well? Let me refresh. Let me close these tabs and see if it's there. So let me try to see if I have a table. Yeah, you can see it's here. We have the well pollution underscore copy, and then when you open it, you realize that it has the same information that is there at the original one. When you just run the original one, you'll see that it is the same. Let me just try to show you that, and I think you know this stuff. But let me just try to run. So you realize that the information is just the same. Only that this one had the filter. Not even, they're just the same. They're the same. They're the same. So we've made a copy so that we can modify. We can make the changes. Here because I'm saying that we need to update. This is a copy. I'll use the copy because I don't want to interfere with the original, and modify the instances where we had this. Let me just copy this command because I want to use it in a copy. Let me just undo this one. Let me put it in this table because I don't want to use again there. Let me paste it here. But now remember, this one, it has a copy. You don't forget that because it will update your entire table. So let me use a copy. The one that I've just made a copy. Then this semicolon I have to remove. So basically, this is the one that we are going to update. So here, let's first of all read. And they are saying, looking at the result, we can see two different descriptions that we need to fix. So the first one that was mistakenly had clean bacteria E. coli should be bacteria E. coli. So let's first of all run this one. The one that I had E. coli should be bacteria E. coli. Then the one that had Gambia should be the one that had clean bacteria Gambia should be with
bacteria Gambia lambi. So yes.
Yes. I think yeah. So you'll help me in case you kind of confused there. You'll help me. So I think let me make this one first of all a comment. Now, so we want to update now this database. Who can tell us which sub-language of SQL we are going to use? The one that contains update.
Sorry. Update falls under data manipulation language, just mentioned that. But what I just wanted to mention is that I think we should first try and see if we can clean it before we use the update.
Yes.
So that it cleans first. This clean bacteria, we remove it, it turns to bacteria lambda before we even try using the update on it. Or what do you feel?
I don't understand.
Okay, so
yes.
this question, they want us to, where it has clean bacteria E. coli, they want it to change to bacteria E. coli. So the clean should not be there.
Yeah,
and where it has clean bacteria Gardiolia lambia, they want it to become bacteria Gardiolia lambia. Clean should be removed.
yeah.
So I'm saying that before we even update it, can't we just use the data query language to clean it first and see it on the table, visualize it? When we see that that's what happens, then we can now use the data query language update to remove it, from the table itself. You understand? Because when you use data manipulation language, it doesn't affect the table itself, just the display. So
no, when you use the update,
when you use data query language, sorry,
yes.
it affects only the display.
Yeah.
So if we can clean it and see it how it displays that it's cleaned correctly before we use the data manipulation language, which is updates that affect the table itself.
Yeah, actually, I think I guess what you are trying to say. Now, what we are using here is we are going to update. So you want the description to remove the any instances.
No, I'm saying that we should not start with the update.
Yes.
We should just fix it without using update first.
Yes.
Then when it works, then we now put update on top to just carry it.
All right. So I think you can give us the command. I think it will be easier. Just give us the command.
Okay, let me just try and look at it well. So, okay, how do we start? Okay, we can select the whole columns and use a where clause where the description is clean bacteria E. coli. Then we now make it equal to bacteria E. coli, and where the description is clean bacteria Gambia lambia, we set it to be equal to bacteria Gambia lambia. Then
yes. It seems now I understand you. I get what you are trying to say. So basically, I just want to see to have the display here and not updating. Just to have
before we update, so that we just see it works.
Okay. Thank you so much. And we are going to do it to select all columns, and then we have to set where description. Is it description? Where is it? Where description is? Where description is?
Yes.
The description is no, we are going to set where we're going to set. Let me just, can I just copy here, or let me just
Yes,
copy
that's better if you
let me
copy it.
let me just copy on this other end so that I may not write
Okay.
my things.
No, you have to copy the other one first.
Yes.
You have to copy the other one first, the one that has claim.
So when you use
Okay,
the
okay, you're correct,
set,
sorry.
yeah.
You're correct. My apologies, please.
No problem. We are learning. So basically this, when you use the set, so this means that this is the new value that you want to update with, and then so you can use now the where.
Where clause.
Yeah, you can use now the where. You can use now the where. You can use now the where. Where description. I don't know if I'm writing my things because when I see errors, I usually feel like I'm not in the right track. But so where description is, so I can copy this part, right?
Yes.
Call it. No, this should be this one. Yeah.
Yes.
Now because it's a string, should be inside the quotes, and I need to figure out first of all why
the error is correct.
Yeah, so it's not. I think there's something that we need to do before we
put set.
Oh, because we have to identify. We forgot to specify the table.
Okay, from.
We forgot. You have to identify first of all the to specify the no.
Select star from. Yes.
Not still is not working. It's not bringing anything.
Is
this it?
Is the set the right?
Oh, let's try to do this. Let's try to add it here at the top. No, not yet.
No. So select. Let me look at it.
Does it have a comma?
Let's change the select to update just to observe if it affects that error.
Update would fix that. Because of the.
Let's try to update. But then when you use the update, so when you use now the updates now, so you should have specified now the the table name instead of the from. But still, this one will affect. First of all, it will affect
the table directly.
We wanted just to retrieve, just to see the
display. Maybe set is now a language for the manipulation.
Oh yeah, maybe there's nothing like that. If you want to
update, if you use set it will update to work.
Yeah, so this one will update everything. But let's just go with this approach because I think
yes.
Let's just do what they're saying. Yeah. So you can see they say that we should update it to that one. So let's just update it, and then we shall try that one in future. Again, now we have the error. Set update. You are using a safe. Oh, by there you have to use now the safe mode.
Safe update equals 0.
So does anyone else knows the command?
Safe underscore update, I think.
Safe underscore.
Safe underscore update. If I'm not wrong.
Column.
Because,
from underscore from. Underscore from. I give it 0. Let me do this. Let me just open here a SQL script, and I think I'll be able to. Yes.
So someone posted the command in the chat.
You posted the command in the.
Someone did.
Let me get there. Oh, this is wonderful. Yeah, this is wonderful.
Why can't I see it?
You can see it. It is in the chat section.
Okay, in the chat section. Okay.
Yes, yes.
Yes, set safe. Yes.
Oh, I see.
Yes.
That's wonderful. Wonderful. So let's run. I think it should work.
Yeah,
I think it has worked. So now can we check? We can check, right? Let's let me copy this part. Let's now.
Sorry, when you copy it and you want to convert it to what they call this thing?
Comment.
To comment.
Oh,
was you press the double what do you call it, hyphen? Does it do on all the copied stuff together, or you do it one by one? Because
if you want to make a multi-line comment, or what are you trying to?
No, for instance, you copied like 3 lines together and you wanted to comment the 3 lines, right? Yes, and you just use the double hyphen once and it affected the 3 lines. Is that how it works?
No. If you want to use multi-line, you can use you can begin with the first slash, then you say it's asterisk. Then
I get that.
Yes.
I get that.
So this one affects only a single line.
Okay, just uncomment the ones you just commented now. Uncomment it. Uncomment it.
Yeah, remove this one also.
Okay. Yes. Yeah, I've got what I want to get. Don't worry.
Yeah. So I think let me do this. Let me just copy this part. We want to see if we'll have those instances where we have where we will have bacteria, clean bacteria. We want just to see if it will be removed or not. So I just want to do a query. So it should return the other one, that head clean, but it's not coli. It's not coli, because this one we removed clean coli. So let's just try to run this one and check if it is really removed. First of all, it seems there's an error here. You can tell us what's the problem. I have an error. Check the nini. I think it doesn't return because it's not there. Is it? Because it doesn't meet but it should have returned something. No, it should have returned something else. Who can tell us what is the problem here? Why it's not returning? Alright, we'll begin with this one. No, this one will.
I think the and is what is making it not return anything. So let's change it to or.
Oh yeah, sure. Let's try or. Yeah. So you're correct. Now let me try to expand this part, but so we want to how can I do this? I want to let me add this because we had the other one that had I think we had for coli, and the other one was for Guardian Liblia, so it should have returned either of them, because they should have returned this one. Even if we used the and, it should have returned, because the statement must be correct because in the description part we had something that has That's and I think there's something that is missing because I want just to return. I want it to return the other one for that is clean, clean bacteria, and then it is Giardia lablia. What can be the problem? Because this statement should be correct because even if we don't use because we already have the clean, we have the the clean in it, the clean. So I don't know why it's not returning. Oh yeah, I don't know what was the problem last time. So I think it has worked. So you can now see we only have these instances for Giardia liblia alone. We don't have that one for coli whatever. I think the coli is updated. So now we are sure that it's working. So I think we can do the same. We can just copy paste. We can just copy paste and then we can just copy paste and then do this other operation here. We can just change instead of coli, we shall change it to bacteria. Wow. And it is Staphylococcus aureus. It's already so I just paste there. Then the other one is clean now, so I think it should be clean something. I don't know if I've copied the correct thing. So is everything okay? I think. Are we together?
Yes.
Okay, good. Wow, this is wonderful. So you can see when it runs with the tick here, I think you get motivated. You know that it worked. Yeah, that's something nice. So let me undo this one and then I try to filter. If it will turn 0 records, then it will mean that it is working. So you can see now it returns none. It means that everything is updated. So I believe everyone has understood. Does anyone have a question here? If not, you can continue to read. So I think we are done with this slide, right? Column from. We are not done. I think we are not done. Let me read this.
There remains the other parts, the Gambia, the Giardia lambia. Have we fixed that?
Yeah, we've done that. I just copied the code for the other one. This one,
Okay.
I think.
Okay.
It was
I think what's left is the results now.
Yes.
So I think what's left is to update the results.
To update the results.
Result column, yes.
Yes, to update the results to be contaminated, right, Anthony?
Yeah. For whatever meet those conditions.
Yes.
I don't understand. Sorry.
Let's go back with that slide.
Okay. Oh, yeah. So let's just read. So the second issue we need to fix in our last is in our result column. We need to update result column. We need to fix to update the results column from clean contaminated from clean to contaminated. Biological, where biological column has a value greater than 0.01. So if you just do let's remove this one. Let me copy first of all because we might want to revert back to this one, I think, in future. So let me just copy and then do a paste here at the bottom. And then now, because of this statement, we can see when you run, it returns 0 record. So this one we can't use it because we've achieved what we wanted. So let me just remove this one. Now, so I want it to return the result is clean, but the biological is 0.01. So let's just first of all run and identify those are records. You can see we've removed now all the instances that had clean bacteria and all that. But so now it is displaying the bacteria E. coli without the clean in it. But you can see it's bacteria, but now at the end it is clean. So they are saying that we update from clean. We updated the results from clean to contaminated, where biological column has values greater than 0.01. So let's just do that quickly. Again, we shall do our copy because I don't want to retype this thing. So what we are changing here is the results, right? We are changing the results. Let me first undo the comment. So we are not now changing the description, we are changing now the results. We are updating the results from clean to something else. So it should be a result. Now for me, when I'm tired, I usually type my things. So let me just do copy pasting. And then here I'll set, no, is it a result? Well, but I believe we are finishing. let me find. I think in fact we're using the table name instead of the column name. So so it should be the pollution copy. By the way, we're using the copy. Copy, and then the columns. Yeah. So the columns, and then we are using the results. So we are now setting the results to clean. Should be clean. So should be clean. So it should be clean. Yeah. Let me just do a copy paste. Copy. So it should be
contaminated.
Yeah.
Should be contaminated.
So it should be by there. Should be contaminated. In fact, I'm also opening other things here. So basically, contaminated is the thing that I want to update. So the set is the thing that we want to modify to, and then the other one is from. So it should be now contaminated, the new value. Then the where description is clean. Is it so? It's okay.
Where the biological is greater than, and yeah,
okay.
clean and biological is greater than 0.01.
So first of all, let's try to understand together. So the second issue we need to fix is in our result column. We need to update the result column from clean to contaminated. To clean to contaminated biological. Should it be contaminated? I think we should also contaminated biological up to this point, right?
Yes.
Yeah. So, and then at the filter should be the filter should be greater than 0.01. So I think the new value should be here. So this is the new value that I want to use. Biological. I think is okay. Now, so the filter here, I want to check where the result. Now we are changing now from description to result. I think this is spelling results. Yeah, result is clean, and then there's another condition, right? Not should we can just use the The biological only.
That because the biological is fine.
We can just use the biological, right? Yeah, I think. God, wait.
No,
You're
we
right.
can't use where the result is clean. It will replace the entire place where the result is clean. We
Yeah.
should rather use,
We're changing the
and we
result
have changed all the biological.
where the biological is greater.
We can now use where the biological is greater than 0.01.
So the where should be where
Biological
biological is
greater than
greater than is greater than
0.0.
wait, I mean it seems like
Once we remove the claims, it will be okay.
yes,
Greater than 0.0.
0.01. I think this way is okay.
Yes.
Okay. So let me run, and I believe we are finishing. Let me hope so. So wow, I think that there's no error. So I believe it's working now. So I think I can comment this one, and then I try to rerun this one, and I see if it will return 0 record. So when you run and you see there's no 0 record, just know that it is updated. So I think we are good up to that. Yeah, I believe people are following and that they are understanding. If they don't ask, someone said that we are assuming that they are okay. So it means that we are good in this slide.
Except anybody has a question, I think we are good.
Yes. Okay. So we can go to the next thing. Someone can read for us. Oh, in fact, they I don't know why I was struggling because I see they already gave us the commands. But someone can just read. For us. But yeah, can someone just read for us? We finish this thing quickly.
Okay.
Is it readable? So, but the thing here is that we can just
What's
check.
the number?
Yes.
20 what?
Slide number 24.
24. Okay. Okay. So case 1A, update well pollution, set description equals to bacteria equally, where description equals to, we've done all that.
Yes.
Then, of course, we repeated it for the rest. So we've succeeded with that one. So we should move to 25. So if we run create table.
First of all, before you go there, let me read this part before we make this change. Or are you reading this one?
Okay, let me read the last part of 24.
Yes.
Okay, now go ahead and fill the rest. Now, when we change any data on the database, we need to be sure that there are no errors, as this could fill the database with incorrect. But is that what you want me to read?
Can you read this part, slide number 24? Slide number 24, the middle line. Before we make these changes. So let me read. Before we make these changes, here is another nugget of advice. Begin a complex query by commenting what you will do. So this step will help us think through the problem before we write the code to solve. And once we are done, we have a well-documented code. Oh, so he's talking about the commenting.
Yeah.
So it is important. So we've also identified something nice from this project that a good practice to document your code when you do the queries and all that. Then the commands that we did are just the same here, updating then a set. So this is slide number 25 here. You can read.
Okay. Let me just be sure that my mic is on. Okay, my mic is on. Sorry. Yes, my sheet.
Oh, I can just read here. I can see this part. You can see. Go ahead and fill the rest. Now, when we change any data on our database, we need to be sure there are no errors, as these could fill the database with incorrect values. So a safer way to do the update is by testing the changes on a copy of the table. By the way, this is something that I said. Before you make any changes to your original data, make a copy so that it will be a safer way. I think also these guys, I think this project is very nice. We can learn a lot. You can see a safer way to make an update is first of all to make a copy so that it may not interfere with your original database. You can read the last part.
Okay. So we will make a copy of well pollution, called well pollution copy. We will now make the changes, and if we discover there is a mistake in our code, we can just delete this table and run it again. So it now shows the code in 26, update pollution copy, set description, okay.
No, I think you're reading the wrong thing.
Yeah. No.
You are in a different slide. You are reading slide number
25, and I'm going to 26 now.
Oh, okay.
We will get a copy of
first of all, let me try to
that's the bottom part. The code is the one on top now.
Yes.
Hold on, please.
Okay.
Let's try to understand first of all this part. Let me reread. Create the create table. New table. The new table, for instance, we use the copy for well underscore pollution copy. New table is then because we use now the AS keyword. If you want to fetch the records or the data from the original table, then here you can add in the query like from the original table that you want to.
So that's what you did earlier.
Yes, exactly.
Yeah, so that's why I said okay, done this.
Yeah. So let me try to read this part until I'm comfortable that we have done everything here. Then we can go to the next thing. So I think up to that point, this approach is a neat trick that allows.
Where are you reading from?
Yes, it is still slide number 25. For me, I like understanding everything.
No, I'm saying that where in 25 is that? Because after this thing in my own 25, next thing is we will get a copy of well pollution.
There are two paragraphs after. Okay, go ahead and fill the rest. So it's really the second paragraph.
Yeah.
Go ahead.
On 25, on slide number 25, the bottom, the one on the bottom, the paragraph at the bottom.
Okay.
It begins with the crate.
Okay.
Yes. So I was just trying because I think I'm a slow learner, so I just want to understand everything here before I go to the next thing to see if I've captured. We've done this one. So the create table new as so the is to make a copy of the other one. Approach is neat trick that allows you to create a new table from the results of a set query. So this is especially useful for creating backup tables or a subset without the need to separate create table and insert into. So basically, the insert into with this is a safer way actually to create a copy and feed it with the to create a new copy of the original table and feed it with the data from the original. So I think this is what we did earlier, and this way I'm contented. I'm satisfied that this slide is done. You can go to the next now.
Okay, I read the next earlier, so should I read it again?
Just read.
Okay, that's fine. So if we run the create table query, we will get a copy of the well pollution called well pollution copy. Now make the changes, and if we discover there is a mistake in our code, we can just delete the table and run it again.
So with this command here, you can create a new table, a new table, the replica of the original, a new copy of the original. But we also realize that it can't work unless you unlock something. We had a command there to I think to change it to what?
No, the command we used was to remove it from a safe mode because
safe mode,
update
yeah,
is,
safe mode, yeah,
yes,
safe mode, yeah.
update is a data query data manipulation language, and for data manipulation language, they affect the table. So all those things are automatically set to safe mode, so that you don't spoil your table accidentally. So you will now have to remove it from safe mode so that it will work on your table.
Yeah, thank you so much. I've learned something there. Thank you so much. So if you want to create a table, it won't work unless you turn it off. You give it 0. When you turn it to 1, I think it will mean that it is now safe. 0 is unsafe, 1 is safe, right?
Yes.
Okay. I think I'm satisfied there. Then if we now run our query description, so I think at this part they are just trying to write the code to update the, to update. And I think this one we did, because I think they are just the same. Yeah, they are just the same. Yeah, so actually we did all of these. It seems we copied them, or are they copied us? Because everything is just
Copy them.
yeah. Everything is just the same. Put a test query here to make sure we fix the error. So we did a test query, and then we realized that it returned 0 record, which means that it was affected. So we can read the slide, or I think we're good here. We can go to the next slide, right?
Okay. We can then check if our errors are fixed by using the select query on the well pollution copy table. So we say select star from the well pollution copy via description like clean or results equals clean and biological is greater than 0 to see whether we get any table. If we get any table, that means there's still error in our table, but if we don't, I think that means we are clean.
Yeah, and I think someone was trying to give us the command with OR, but I think I wasn't getting it well. But I think he meant this one, this part where you can use this OR. But either ways, it will return the same results. So let me just try to run again this one. Let me run this code. I believe it's okay. I believe it's okay. In fact, it has the errors. Let's just maintain ours. I think there's an issue somewhere. Let's just I don't know. I want to complicate stuff. I forgot to mention the database. I remember you have to specify the database. The database, yeah. The database name. Yeah, when you get 0 record, it will mean that it is okay. So we also did hours. We also did hours in the result were the same, just the same. Yeah. So you can see it returned the 0 record. So we are good here. And I believe everyone is comfortable. If we go to the next slide.
Okay.
Yeah, you can read this part.
It seems we are finished.
Wow.
It's a lie.
Well, congratulations to us. Yeah.
Are you sure that this is not the shortened version?
I think it had something like 40 slides. I think they see that we could go to 4 p.m. To 4 a.m. So I think they shortened for us. Yeah. So I think it has been productive. I think I've gained something from this project. I've learned a lot. Learned from you guys. So
okay. Yeah. I think we should just do that thing we were trying to do earlier. rather than saying update table,
Yes.
let's try and see if we can replace the string, that string with maybe we say when we select so that we can see how it affects before we do the update.
Now I know what you want to, but I think that one should be in the next next modules and the next because on this was just the basics. These are in this part one. I think it was just the basics, the set, update, and other stuff. But if you want to use those alias, for example, AS and modify the the
No,
preview.
no, I don't even
Is
want.
it in this?
No, it's okay. We'll need to modify we'll need to use an alias to create a new column
Yes,
for
yes.
it to work. Okay,
Yeah,
okay.
that
I
one
thought
is
we
in
could
the.
modify the column directly.
Yes, no, I think we can do that, but now that one falls in the next part, next
Okay.
bit. Yeah. So I think can we? Is it in order if we do the test? I think the test for MySQL, that part.
Okay,
Yeah, we can
okay,
just
okay.
go to sleep. Yes.
No, no, let's do the test. Let's do the test.
Okay. But there, you Nigerians are in good time because I think we have the time difference.
What time are you?
And our end is near 1 p.m. But let's just do that quickly.
Okay, ours is close to 12. Okay.
Yours is close to?
11.
Oh, yeah. Yours should be earlier. Yours should be earlier. Let's just do it quickly because now we have an understanding of the data. We can do the test just quickly.
Quickly, yeah, exactly.
Yeah, let me just copy this part. I think we can do it. We can we, how can I do a preview or a practice test? Let me try to review the test here.
I don't know.
I'll be able to download there. Yeah, download the answers. So let's just download these answers and try to go through.
Okay, you have I don't, let me see. Not seen that before.
Yes? Oh. Okay, yeah, I think I think it's okay. We can we hey, it seems it's many. Can will we finish? Will it
It's
be
10 questions now.
Okay. All right. So the first question quickly.
Let
What
me
is
look at it.
yes.
What is the address of Bello Azibo?
Bella Azibo.
So we just go to the.
So you can just tell because now we are familiar with this. This project has helped me to learn a lot how to understand the data, tables and all that. So
Okay, which table has addresses? We have.
For me, I just guess that table must be relating to maybe the employee because
Employee, exactly.
Yes. You can just
yes,
in fact,
you're
it's just
correct.
the first. In fact, it's just the second record.
In fact, select this thing from employee. Let me check it.
First of all,
I'll just change it. In fact, I'll change select staff from employee from employee column where employee name equals.
Oh, so I think here we can quickly tell because it's here, but now we want to use it as we want to use a code so that we get to understand. Perhaps it were in record number, whatever, thousands of record. So we need to use a filter here. Let's just use a filter. So we'll say where employee name, right?
Yes, employee name.
I usually type wrong stuff, so I like working
with copy. Just copy directly.
Paste. So employee name, where employee name
equals
is a string.
That name they give us. What name did they give us again?
Let me copy the other end to be sure that I'm copying the exact.
Yeah, Bello Azibo.
Bello Azibo. I think
Yes.
okay.
Just direct like that.
Yeah.
And the
So they
address
say
is 129 Ziwa.
121 Ziwa Lakio Road.
Wow.
121 Ziwa Lakio Road. Yeah, it is this one.
Yes.
Yes. And then there's this explanation here. I think there's no need for that. Let's go to the second one.
Yes.
So what? Yeah.
I
What is
noticed
the
what's the phone,
Semicolon
what's the
after.
name and phone number of our microbiologist? So I think we are still in the employee column.
I
But
think before we continue, I think someone was talking.
okay, sorry. Who?
Yeah. Yes,
Okay.
in that code for Bello Azibo, I noticed that you didn't put the semicolon and it returned the address.
There is actually it's not a must. It's not a must by the way. It's just a good practice to put, but it's not a must. It's not a must to put the semicolon. Just to show that the end of your query is not a must, but it's a good practice to do so. So I think for me I used a bad practice, but it returned. Now a good practice is to add the semicolon here at the end. You know.
Thank you.
Yeah. Okay. So question 2. Question 2 it says, what is the name and phone number of our microbiologist? What is the name and the phone number of our microbiologist? The name and the phone number of our microbiologist. Does this question just begin like, let me just first of all, position microbiologist. Let me just comment this one. What is the name and the I think they are referring to Bella Azibo, right? I think they are referring to the same. Or it's me who is not getting it right. Because here they say, what is the name and the phone number of our microbiologist? I believe we can have several people with the same position, microbiologist. Alright, just one microbiologist. So I think yes.
They say the same table. We'll just change the where employee name to position. We will select employee name from that table where the position is microbiologist.
Yeah, so what is the name and the phone number of our microbiologist? So I think I will have one instant because they haven't specified the name. I think we can do the query with the let's do the position. Let's say position.
Yeah.
Let's say position is micro something. Let me copy the other side. Microbiologist. Let me do that. Microbiologist. Microbiologist. Where position is microbiologist. Let me run. No. I think it should be like. We should use now the like, right? I think it should be where position should be like.
No.
Is it? Yes.
Okay. Yeah. Yeah.
I think the issue here was here. I think I had the white space. Yes.
And I think they put a space between the micro and the biologist.
Yeah, I think I have just realized that was the issue. You know, sometimes when I'm tired, I usually do wonders. Still it's not working. So I think let's try to do with the like.
Okay.
Let's try to do with the like and see if it will. Is it really position? Did I use the correct name at position?
Yeah, the position.
Yes. Biologist. I believe it should be correct.
The problem when I was doing this, the problem was there is a space between micro and biology. So I didn't know how they expected somebody to get that thing right.
Let me by the let me just, I think they are the ones who had the problem. Let's try micro. Oh, in fact, I'm the one who should be micro, then bio or underscore
Exactly.
biologist. Let me run. Wow. This is very, very wonderful. Microbiologist. So you can tell it is what they ask the name and the phone number. So it is Voyosile Gadir. Voyosile Gadir. Which was that Voyosile Gadir. Now you can see we have two instances of Voyosile Gadir. Now the next thing, I think the one that we can use now to identify is now the phone number, because we have two instances. So you can check on the phone number. You can see the phone number here, it ends with 36. So within those two names, we can check the one that ends with that 6. I think that it is this one, because this is the one that ends with that 6. Yes. So are we good up to that? We can continue.
Yes, please.
Okay. So what is the source ID? What is the source ID of water source shared by most number of people user comparison operator? So what is the source underscore ID of the water source shared by the most number of people? So I think here we can do the order by, right? The descending, then I'll identify the one that order by, then ascending. Is it descending?
It's descending.
Descending. Okay. So first of all, I think it is source, water source, yeah, water source. The number of people, many number of people. So I think I can just guess it's water source. Yeah, it has the number of people. So in this case, we'll do a filter with the where. With where.
Please, can you just show the question one more time? Let me just look at it.
Yes. So what is the source ID?
ID of the water source shared by the most number of people. Hint, use comparison operator. Okay.
By the
Okay.
do we need even the where? Oh,
Water
of course. Must we use, or we can just use them?
Select star from water source. Yes. I don't think we need to use where.
We don't need, because
Select star from water source.
Then
order
by.
No.
Descend. Yes.
No. If we order by.
So we want to order by the any. We want to order by the number of people served, I guess.
Yes, we can try that.
So it's water source.
Say order by the number of people, or group by the number of people.
No, not the group. We are not doing the aggregation here. I think it's just the number of people.
I want to check the most number of people. So
yeah.
Order.
So a number of people, and then as you say that it is descending. Is this the spelling for descending? For that keyword?
Yeah. I think that works.
Yeah,
okay.
So,
let's see.
Okay. Yeah, it lists.
Yes, works.
Yeah. Now, okay, the idea are the same. So the idea should have how can I master this one? No, the idea are different. 3998. I think that there are several instances. We have two of them. 998.
We have no, they're asking us for source ID, so we have 24,
24, and then here at the start you can see the one begins with the HA, then the other one is AK. Let's
look at the options available so we know what is the source ID of the water source shared by most number of people.
I think it should be the first one. So how can I do that? How can we compare? How can we filter? That's or we can try to master. Can we say, let me try to cram HRU 19. Let's try. HARU 19 is not there. So let's go to the next item. Oh, and by the way, we could filter even, we could use the filter so that we may just have this, return these three instances. These fightings.
Wait. Another thing sorry. Okay. Yes. This AKR. Check your second one. I think has 224 as the end.
AKR U05 accru 05.
Let's just say accru 05.
Yeah, accru 05.
Accru 05. That's it.
Yeah,
that's it.
That's it. Yeah, though I think the other approach, you could filter. You could filter based on these IDs. You could filter based on these IDs, so that it will as well be easier. But all in all, that is the answer.
But that will be. Let's write the command.
All right.
Where in, instead of select where in. Then we'll just copy out all those.
Where in now the nini should be where in then we specify the source ID, right? Where in source ID, right?
Source ID, yes.
Then specify.
Then we drop
where source ID in.
Oh, where source ID in, by the way. Where source? Yeah, sure.
ID. Yes, where source ID in.
Then I shall add the range. So it's a string. You say that you have to use two quotes. And then the other one, let's just copy. I think this way it will be more easier than guessing things. This other one is this one. I believe people went to sleep. How many are we there?
It's nice.
How many are we there?
We have 1, 2, 3, 4, 5, 6, 7, 8.
8. Oh. Yeah, this is nice. Though, the goodness we are recording. I hope I'm recording. Yeah. So.
Please check again.
Even if I check now, you've covered that.
It's late, but it's a beneficial part.
Yeah, we are praying that I did. So, yeah, you can see.
So just hit that one as number 1.
Number 1.
Yeah.
So this is just straightforward. So there are several approaches on how you can kill a rat. Ways on how you can kill a rat.
Okay, number 4.
Yes.
What is the population of Majidongo? Start by searching the data dictionary table for the word population. So it just wants us to know which table has population.
Oh, okay, the hint. So just to get to know the population.
Well, let's even try searching that data dictionary and see how it pops up.
Okay, so let's
copy the Majidongo so that we don't need to come back.
Yes?
You can copy the Majidongo.
To copy what?
The Majidongo, the name they say we should search, you can copy it from the question.
Oh, I think I know the name.
Okay,
so
you know the name, sorry.
Yes. So from select data dictionary where let's do this. Let's say where.
Select this
where description. Let's say where description column. Now, sometimes when I type, I usually type my thing. Where description.
How do we know it's going to be in description?
Most likely because
Is it
the
name?
data type, yes, and because
Is it
the
name?
column
Okay.
name, because the column name cannot contain something like margin.
Yeah,
Or
yeah.
not,
I agree with you. I agree with you. I've
but
understood it.
I think that's not the the population. What is the population? The population.
But they want us to first find, okay, population. Okay.
So I think that the filter should be population. Let's try to search for
Yes.
population. Yeah,
So population most likely should fall under column.
yeah, column. Yeah,
Column name.
yeah, column name. So it should be something. So we use the like, right? We use the like, and then it should contain something like population. So we use the wildcard character. Then for population, just do a copy paste population. I think I'm writing the correct stuff. Population, where description like for population. So let's just search something like that, so that yeah, you can see we have so you can see it tells you the table name. This global water access. Though we have two instances of the population. The national population says in thousand, then at the urban. So we are going to check on the national, because I think that Majindogo is like at the nation. What is the population of Majindogo? So Majindogo, I think Majindogo is like a country. I don't know. So I think we should go with pop N national. Yes. So I think with the data dictionary, you can quickly identify the table name under the
So
column name.
okay, we found we didn't find population size estimate. Okay, I think that's more likely.
Yes. So
Under the global water access table name.
here.
Global water access, yes.
Yeah, so it's here. And then pop N, the national population. This one. And then so the national population. So for Majindogo, I think I'm from Majindogo. So we can do a filter there. Where? So where, and then I will realize that we are using now pop U, right? It is pop N, pop underscore N, pop underscore N. It has something like, or is it a direct match? Majindogo.
Pop N is equal to.
No. First of all, I think now this pop U, this pop N should now display the population size. I think now we can use the name, not pop N. So we shall check on the pop N to check the size. But now the filter should be Majindogo. If we want to obtain Majindogo, we should use the name, right?
Yes.
Yes. That should be name. And then Majindogo. I don't know if
when name like
Majindogo. I think it should be a direct match. Let's try to run this one first of all. Then I should try with the like. Yeah, we have Majindogo. Though we have two instances.
And they are both the same?
Yeah. Yes?
The figures are same for both years, 2015 and 2020.
Oh, you can see, basically the population is the same. Yeah, I think, yeah, we are good. 27, 62, 8.1. And the other thing, you saw the... Now, when you go to the data dictionary, you can see the national population estimate is in thousands. It is in thousands. So when you have this one, and then they want you to convert maybe in millions, I think you do the division. You do the division to convert it now to millions.
And now just division. 2, 3.
Yeah, so I think it should be 27.6281 million. Yeah, let's check. Yeah, 26. I think they rounded off. Let's compare. Let's check. 20 should be 26.6. Yeah, when you round off 2, I think you can't round off 2. So it's 27.6. Yeah, 27.6, I believe. Yes. Yes.
Let's go back without those options again. I want to know why it's not the other ones.
Why is not what?
Let's see the options again, please.
So the question.
Yes, the question. So I see now. I was looking at the people. So yeah.
Okay.
Yeah, it's million. So basically they use thousand, but you have to convert it.
Million, yes.
Yeah. So this is people, not million. Should be million people. Yeah. So which query? Can we go to number 5?
Yes.
Which SQL query returns record of employees who are civil engineers residing in the hub or living on let me read. Can someone read for us kindly?
Okay, which SQL query returns records of employees who are civil engineers residing in the harbor or living on an avenue? So it has to be or. So the position has to be civil engineer or address living on an avenue. That means okay. So we have
the all will be between the harbor and living an avenue. While civil engineers will after civil engineer will be and.
An avenue is not a direct place, so something avenue. So we have to put the percentage sign beside avenue. But civil engineer has to be direct, so we have to use equal to and quote.
So with this statement, for it to return, the first condition that should be met should be civil engineering must be there. Then the and then the next thing should be, so this should be something like in a bracket, like you can have either of. If it returns the hub or avenue, either of them, when it returns all of them, it will mean that that statement is met. When it returns, yes. So I think with these ones, it is always easier. It is always easier because you can just copy paste. You can just do it. You can just copy paste in the run and see if it will return those things. The only thing that we are changing or adding is the database name, because if you don't add, you'll get an error. Let's just run. So the first condition that should be met, you can see in fact this one, it doesn't return anything. So this one we can just exclude, right?
Yes.
This one we can just exclude.
Okay, we are just using the command directly from the answer, right?
Yes. We are just copy pasting. So let me just copy this part. Then so let me paste in here. Now let me run this one. Then now this one returns. Let's first of all let me reread the question. The SQL returns. So the first thing that should be returned, that is a must, should be the civil engineer, and then should be living in either the harbor or avenue. So let's just take those two. Living, residing in the harbor or living on an avenue. So we should look every instance that has an avenue in it. So yeah, so you can check. You can see these two has avenues and the address. So it's avenue, and then we also have avenue. Then you can see the one that it has returned is civil engineering. So it means this has met our condition, right? Because at the first one that was to be a must, it was civil engineering. Then the second option was either the avenue or residing at the hub, let's check, the hub, the hub. So I think this statement she is correct. She has returned what was asked. But let's check the rest. Let me copy and then I'll place it somewhere. Now, with this one, you can just tell, because at the first condition that it was to be unique. It was the engineer, something engineer. It was a civil engineer. So you can see in the position we have field surveyors and other stuff. But in the address, remember in the address it was either. But now the first condition must meet. So if it's not met, even if the rest are correct, you can just tell it's wrong. Right?
But when we run it, it's not supposed to show position for field, because it's supposed to first pick the first part where to run to run the one in the bracket first.
To run the one
in the bracket.
The one in the bracket.
No, we don't have a bracket in our one. So.
Yeah, so I think the key thing, you can just check the results here. You can see the first condition.
So that means
yes.
If we don't have a bracket, then that means where position equals civil engineer should run first. It should first look for civil engineer before it looks for that.
Yeah.
Position field surveyors.
So the question is, why is it bringing field surveyors?
Exactly.
Yeah.
Because.
So it is returning field survey, and the condition it was to return only civil engineering. So this one can just
can we select staff from waters, be a position for civil engineer and progressive possibilities
Are you in agreement, or you are?
No, we don't have any doubt that we have the answer. We're just trying to understand
that one. If we remove the and part, let's see, maybe remove the and
so it means that
from and downwards. Just you can comment the and downwards.
Now,
from and.
Let me just comment this one. Like this.
Yes, they remove and. Okay, they run it. Let's see, maybe it.
But now we were trying just to check.
Okay. Yeah, we are just trying to check.
Yes.
So okay, so that works perfectly.
Yes.
So and let's put the and first.
So there were two optional aspects. Like so, the first one was for it to have either the harbor, residing in the harbor, or living in an avenue. So region, I think it's regional address should be maybe either the harbor or an avenue. So like you can see, this one is a civil engineer, but there's no the harbor in it. But these two, they have in it avenue. So it means either of these two should be correct.
Because it's all, so it's not compulsory that it has avenue on the harbor. It's either the harbor or avenue.
Yes. So even before you do the rest, you can just tell that that's the correct answer. Yeah, because you can select two options. But let's just try. Let's just run. This is multiple choice. Multiple choice. Should be up to this point. This one is, you can see the position is already severe, so this means that it's not correct.
This one is also like that other one that we're trying to figure out.
Yes.
And the key to it is that
Fixing it is to put all those things in a bracket.
yes, the civil engineer and the Habu are working together in these wrong options, while the O is bringing the other options.
I think what is happening is that those ones in the bracket, when we put all those things in the bracket, like that, like the answer, it checks for the ones that match that. Then that civil engineer becomes a strong query to answer that. But when it's not a bracket, each of them are strong enough. I don't know, maybe, it's just like putting weight on the query.
Yeah.
If you remove the brackets,
yes, each of them have equal weight.
Civil engineer and the Habu now act as if they are in a bracket together.
Yeah.
Because of
no, I think that if they are not in a bracket, it means that civil engineer, the Habu, and Avenue have the same weight in terms of power to search. So if it's not this one is there. So it just brings out all of them. But those ones in the bracket, if we put it in a bracket, we turn all the weights of the Habu and Avenue to become a single weight. It checks for both of them. Then now civil engineer and the result of both of them now fight.
That's exactly what is happening.
Exactly. So when you add it in the bracket, so it means that these two conditions must be there. It must, in the position part, it must be civil engineering, and then in the province name, it must be the Habu, and then this one can be optional. For example, they like.
Yeah.
So I think it will return only this.
Let's look at the question so that we can have an idea of what to be putting in the brackets.
Yes.
Which SQL query returns the record of employees who are civil engineers residing in the Habu or living in an avenue?
Yeah. So these two are arguable.
Yes. So civil engineer is a single thing. They want the Habu or avenue to also be a single thing. Okay? Okay.
So we are good there.
Yeah.
Let's go to question 6. Create a query to identify potentially suspicious field workers based on anonymous strip. This is the description. Create a query to identify potentially suspicious field worker based. I think someone can just read. If someone else read, I think I'll understand better.
Okay, so create a query to identify potentially suspicious field workers based on an anonymous tip. This is the description we are given. The employee's phone number contained
86. Contain the digit 86 or 11. You can go.
M. The employee has a field surveyor. Or the employee was a field surveyor. Which option is correct?
Yeah, so let's try first of all to understand the question. So here we are trying to identify the suspicious workers, the anonymous strip. So this is the description. So the first query, the employee phone number should contain either 86 or 11.
So like 86
or 11. So you can, these two are optional. You can either be 86 or 11.
So they'll be in a bracket.
Yeah. And then now the second query, the employee last name started with either A or an M. So it should be an AND. Yeah, so these two conditions must be met. And then another AND should be the employee was a field surveyor.
So field surveyor will be the strongest weight.
Yes.
So the other two will be individual brackets each.
Yes. So all of them will have the AND, but within this one, for example, 86 or 11, it will be inside the bracket. They are optional. It can either be 1 or 1. And then this one also, it is an OR. So I think I can do a quick query for that.
So that's the last query. We just change the.
Yes.
Yeah. The last query we were working on We'll just edit it. That's all.
I think we should just try and do the query.
Yeah, this one you have to write the query. This one we are not doing the copy pasting. You have to write the query.
Yes.
And I check. So most likely we are using the employee table. We're using the employee table, and then now we are going to use the filter where. So the first thing is what's it name? Phone number.
Position is
I think it was the first condition was let's begin with it, because this one doesn't have that or. Let's use it as a first argument. Yes. Right? So let's use position, where position is so this should be a direct match. So I'll say field surveyor, and then I shall use the and phone number. So we go to the phone number, right?
Yes.
So phone number
Like.
should be so phone number should be like and then into, because they are optional, should be either of them. And then now phone number here, the first one was, the first argument was
the 11 and
86 or 11.
I don't know. I don't know why I'm sleeping here.
86 or 11.
86 or 11. So we'll use this wild card. 86. You say the 86, and then or is it?
Yes.
Wait. Is it so?
Yes, you just continue. I'll still say something.
No. I don't think so. I think what we'll do, we'll have to write different queries here. We will say where, then he will say where, then I'll say here 86, and then yes. Oh yeah, here at the end as well. And then now or again I'll use now the like again.
Yes.
And then we shall say it is 11. So string first of all, then it is 11, should be 11, but we need to add something inside the brackets.
But you're putting from no.
After the and.
After the and is where you're putting in bracket.
Exactly. Okay, sure.
Then yeah.
Yeah, let me remove this one.
Yeah.
So this should be correct. No, but I should have specified again the phone number. So let me just copy or phone number. I think it's correct. So this is the second condition. Then again we shall use the and. So what was it? Last name. Name. So we have the name. So we will use the employee name. So again we shall use the the what? Or it will have the or, right? Well, so where employee name, it will have the like. Again we shall use the like.
Yes.
And then now, because I want to retrieve the last name, so we can do
underscore.
Yeah, we can do. No, it doesn't have the underscore. We will as well use the wildcard, but now to separate them, we shall use the space, the white space here. We shall use the white space, and then followed by the name they gave. And because we want to obtain the last name, and then I should begin now with the last name begins with the A. So it should have a white space. Let me ensure that I have single white space. So that to separate, like you can see, yeah, it should be, no, it should be percent, right? Percent. Yeah, like this. And then or let me go copy this stuff. Now here we'll change here to M, so that we can only forget the last name. These are stuff. So employee name, yeah. So it should be inside the brackets, I guess. So well, do we have any other condition? I think we are good.
Yes.
All right, let's try to run. So first of all, let's go to the question. Create a query to identify potentially suspicious field workers based on the anonymous. This description. What is the option? So the employee name. So we can just check on the names. The employee name. So the first one that began. The last name began with A. Then the other one began with M. The last name began with A and M. It is Bello Azibo and Azuriel Matembo. Bello Azibo and Azuriel Matembo both fit this description. I think that this one is correct.
Yes.
So let's quickly go to the next thing. I think we are done there. Or we can check on the rest.
No.
Yeah.
We are good.
Yeah. So you can read for us, kindly.
Okay, what is the result of the following query? Choose the most appropriate description of the result set. Let's start from the well population, where description like clean or results like clean and biological is less than 0.01.
Oh, so now you can see now the goodness of not altering the table, the main table.
Yes.
You might want to refer to it later. So like if we could have modified the original table, I think we might fail also the MCQ this part. So let's just copy and try to filter now with the original table.
No, I think the clean table.
Yes.
The clean table.
What?
Is the table we cleaned we need to run the query on?
Yeah, it is this one. Basically, the well population, then where the result, it has clean. So we're just writing this query to see if it will meet, if we shall obtain something that meets these specifications. I think it's correct. Let me run. Yeah, so I think we can do the count. They say what is the results of the following query? Choose the I think here they are checking on the number of records, so we can do the count.
I think it will appear there. The count will appear.
Yeah, we should use the count.
No, I think if it's number of records, I thought it will appear on the on this bottom side. Yeah.
The bottom
side. Did you remove the limits at this time?
I don't have any limit here.
You have limit of 1,000 rows up.
Limit of 1,000
rows up. Look at the column where you run the query. You will see limit to 1,000 rows.
Oh, this one.
We don't need any limit for this question.
Okay. I think I have also learned that. I didn't realize. So let me run because I want to obtain the number. So let me run. It is a 4954. 4954. 4954. So not.
No. 4954 is incorrect. Are you sure we are using the cleaned table?
I think here we are using the modified table. what is the result of the following query? Choose the most appropriate description of the results. Or where description like clean underscore or result is equals to clean and biological is less than 0.01. So 0.01. So I think we should use now the other table. We should not use the copy table.
Yeah, let's try the copy
because this
table.
one is modified. It should be the, and I think the result will always be there. If you have a wrong result, I think they'll add it there. As you can see, they have 1954 return. This grade is coming. So it will always return. So let's use our copy table. Yeah, 4916. Yeah. So by there you have to finish those.
I said that copy table is the one with modified.
Yes, and that's what they want.
And the modified table is the copy table. That's what I was trying to say the other time.
Yes. So the copy. So this is the accurate one, the one that we have filtered. We have done the cleaning.
Yeah.
Yes. So I think we are good. So 4916 records are returned. So by there, I think before you do this test, I think you have to finish that part. That MCQ work there,
Okay, question 8.
Yes.
Which query will identify the records with a quality score of 10? So we just need to look at it objectively.
Yes. This one we can't go even to the query. Just check. So
let's start from water quality where visit count is equal to 2, or subjective is not all, because we want the water quality to be equal to 10. So that cannot work.
Yeah, so it should be and. So anything that has or
cannot work. Yeah. Select star from water quality where visit count is greater than 1, and we are not looking for greater than 10. We are looking at equal to 10, so 2 cannot work.
Yes.
Select star from water quality where visit count is equal to 2 and subjective quality score is equal to 10. We cannot put this one because there is no mention of visit count in the question.
So visit count is there, but now the key thing here is they said more than. When you say more than, it means that you have to use the angle bracket.
So either 2 or more, greater or equal to.
Yeah, so it should be either equal to 2
I didn't see the visit count in the question, I'm sorry.
Yeah, so they visited more than once.
More than once.
So basically we are there checking on the visit count. And then at the last one, also the statement can be true because it has the and that's the first thing that you check. And then at the next thing, they say that the quality score of 10. So this should be exact 10, not less than or equal. It should be 10. So the quality score should be 10. And then they say that visit more than once. So it means can be greater or equal to 2. So this remains the correct option, right?
Yes. Let's go to 9.
You have been. Can you read it kindly?
You have been given a task to correct the phone number for the employee's name Bello Azibo. The correct number is, write the SQL query to accomplish this. Note, running these queries on the employee table may create issues later. So use knowledge you have learned to avoid that. Okay, so we want to first update the table. We want to set the phone number to the number they say is correct and locate the particular employee, because if we don't use the where clause to locate the particular employee, all the phone numbers on that table will be replaced by that.
Yes. So this second option, first of all, because we don't have the where, we should filter it out.
We should run away from it.
Yes, exactly. Exactly. And then now, so let's try it. I think this one was correct.
This
Let's
third,
begin with the rest.
this third one says where name. There is no column named name.
Yeah,
No
it's
one
employee
can
name. I think it's employee name. When you go through it, it is listed as
employee
name.
name. Check.
Employer here, employee table. It is employee name. It's not name.
No name.
Yeah. So that one you can just filter it out. Then at the fourth one, now the difference here, this is like it is defining it as an integer.
As an integer, whereas phone numbers are saved as text.
Yeah, they are saved as text because of
As
this
strings.
plus. Yeah, because of this plus. So this one, just filter it out. Then let's check on this one. So the phone number, it is this one. Then where employee name is Bello Azibo. So I think this one is correct. Right. So is there anything in explanation here? This one is just correct. Right? Do you have something to add there?
You're correct, yes.
How many? Can you read?
Okay, how many rows of data are returned for the following query? Select star from well pollution, where description in or results equals clean and biological is greater than 0.1. So the query is basically saying
Just copy and run.
just copy and run, exactly.
Yeah, sure. And then now this one we are going to use the updated table.
Yes.
Yeah, we are using the updated table. I think it was somewhere. Let me just, I don't know. Let me just import the database to here. If this is MCQ1 and we have gone up to 1, by the way we began late. So no, we need to do a count.
Try the other method of removing the limits, like he was telling you earlier. You know what I'm saying?
To
the other method of removing the limits.
The limit. So it's already removed. I think you can only remove once. Yeah. And then we say that we are using the copy, the updated. First of all, let's run this one. I think that it will be an answer for that.
Is this the copy?
Yeah, no, this one is the original. And I'm just trying to say that you'll always find the answer. The answer is even if it's.
This answer cannot be correct, though.
It cannot be correct. Let's just check. I think it will be there.
It will be there.
It's already, it's already there. So
but run it on the copy. I'm sure it's
copy. Yeah, for copy, I think it will be updated. So copy.
Wait, is the select count there?
No, because I think when you just see the results, you can see it counts on row, so you can tell that it's a count. You can do a count.
How many rows?
By there they are asking how many.
Yeah. I get what you did there.
Yeah. So we are doing a count on this copy version. And the next one. And then we found 570. Yeah.
Correct.
Sorry.
But remove the count. Remove the count. Let's see what comes up.
So when you remove the count, it will return everything, not the.
Then it will show at the bottom.
It usually show. I don't know. Let me run. Or I should have highlighted and then run. Where in the bottom?
It's supposed to show.
You can as well by there use the GUI to count. These are query stats.
Yes.
Query stats. Yeah, so let me get somewhere. So you can see the row sent to client is 570. So you can as well use this side. 570. They all return the same thing.
Okay.
Yeah. So I think finally we are good with the MCQ1 project.
Yeah. I hope tomorrow is as smooth as this.
Yeah. But today, tomorrow as well, we shall try to make it smooth as this one.
Well done, guys. Great job, great job, great job.
Yes, yes. First of all, let me see.
Oluwatoyosi did not sleep. Please give that woman a beer.
Let me see who persisted, who persevered.
Yeah, I'm here. In fact, my son is throwing up and everything, but I'm still listening to you people.
Well done, well done, well done.
These are serious people.
Lucy, unmute your mic, unmute your mic.
Let me know who Kenyan
Hi
is here.
guys,
Hi, Lucy. How are you?
fine, thank you.
Hi,
Well done.
Lucy.
Hi.
Hi, any Kenyan here?
Yes,
Anthony, thank you very much. Oh, your insight was very helpful.
Pleasure, man. You guys do well.
First of all, let me see if
Victor,
there's a
no
Kenyan
retreat, no
here.
surrender.
I think the Kenyan non left. They went to sleep. I think it's already 1. I think the Kenyan, they went to sleep.
I'm Kenyan.
Lucy is Kenyan now.
Oh, wow.
Masundo is also Kenyan.
Wow, they have their resilience.
Jacob is also Kenyan.
Is it a resilient or what? Or a perseverance?
They are doing hard things.
Until they speak up, we're not sure they are not asleep yet, though. Until they speak.
But at least they left their data running.
Yeah. So this is great, guys. I think we've learned something together. Yeah, because I know on the exam, I think they'll test because the exam will cover.
But wait, how will the exam be different from the test?
I think it is multiple choice still, but
Okay.
I think it will have more questions. I think I haven't opened.
I think it will be more theoretical. I think the exam will be more
It
theoretical.
has 15 questions.
15 questions.
The exam.
Yeah, the movie database. I think it has 15. I think I saw something like that.
Wait, is it this kind of running test, all those kind, or is theoretical questions?
Is it multiple choice?
Similar to what we. I think it's similar to what we do.
Yes.
Only that we are using a different database, and the questions are more like Nehemiah said.
Okay.
Yeah.
So
And I'm sure there's time limit.
Yes.
No.
It's not timed.
Thank God.
I don't think so. Well, I'm not sure. Let me not lie.
It's not.
So I think what we'll do tomorrow, we shall try to go through
MCQ2.
If we won't finish, I think we shall go straight away to, or I think the deadline is next week. The deadline is Monday.
But it will be good if we can finish this weekend.
Yeah, I think if we will not finish the MCQ2 tomorrow, I think the next day we shall go straight away to do the MCQ3, the test, before we go to the slides, so that we may just put that aside. We say that we are done, so that we can go freestyle.
Yes.
So guys, I really appreciate for your cooperation here, and let me see if I recorded. Yeah, 4 hours. Not a joke.